Peak human.
Les humains à leur meilleur.
C'est tu apogeo.
Peak 人間
Peak humano.
We're back for the conclusion of this mighty animal versus plant food discussion. Paul is a beast on this science, and I think it's really interesting to think about this in a whole new way than most of the mainstream nutrition world has for the past 60 years. We're a day late because I've been desperately trying to launch my grass-fed meat company, Nose to Tail, which you can find at nosetotale.org, which we mentioned in this episode. I couldn't release this episode until the website was live. So guess what? We're now selling grass-finished American-grown beef raised in the heart of America in Northeast Texas as of right now. I've spent over a year figuring this out and searching for the right ranch to partner with. My guy is the real deal. We have grass-fed, grass-finished beef, buffalo, and lamb, pasture-raised omega-3 pork, and omega-3 chicken. We specially formulate the diet of the pigs and chicken for an incredible omega-6 omega-3 ratio, which is 1.5 to 1 to 1.7 to 1. This is huge. If you've been listening to the experts I've been interviewing, we want our ratio to be right around this range. We sent the pork and chicken to a lab for analysis, and you can see the full fatty acid profile results on my site, nosetotale.org. To give some context, this blows away even pastured poultry, which has an 8 to 1 omega-6 omega-3 ratio, and free-range poultry, which has an 18 to 1 ratio. Our pork tested at 1.5 to 1, and conventional pork is 20 to 1. This is great stuff. I'm most excited about the primal mixes. We have beef, buffalo, and pork primal mixes with either 30% organ meat mixed in or 5%. We're talking liver, heart, kidney, and spleen. You can get all the extra nutrients without dealing with a taste that is harsh for some. At the risk of going on too long, we're also offering tins of cod liver in their own oil, wild-caught sardines, and bone meal. These things round out the ultimate nose-to-tail diet and what I've been eating regularly in my diet. So many great things with these, including huge amounts of omega-3s, huge amounts of vitamin A, calcium, magnesium, phosphorus, the list goes on. Just check out nosetotale.org and check out all the boxes and products. I'm so excited about this. I can't believe it's finally here. This is such a win-win-win-win-win. It's good for your health. It's supporting an amazing ranch. It's helping regenerate the soil and environment. The animals are raised well and they're happy. And it even supports me so I can keep putting out this content and finish the Food Lies film, etc. Thanks so much, and I know you're going to enjoy it. Now on to the rest of the discussion with Paul. We cover everything else you can imagine, from coffee, more plant toxins, longevity and anti-aging research, the blue zones myth, advanced glycation end product, and heterocyclic amines in cooked meat, Mtor, the balance of methionine to glycine, which is another reason why you should eat Nose to Tail and why not buy it from nosetotale.org and get the best stuff around, Paul's workouts, inflammation, ApoE4, safest plant foods, and more. This is an episode where you really need the extended show notes Christy has been doing that are available to Patreon supporters. You can go to patreon.com/peakhuman and support the show there and get access to the very comprehensive show notes she puts tons of time into from this week and last, plus from Dr. Thomas Seyfried and Dave Feldman. So now you have a whole bunch of ways to support the show and the film, from $2 on Patreon to pre-ordering the film and getting your name in the credits on Indiegogo, all the way up to a giant $200 box of grass-fed meat delivered to your door. I really appreciate your support, and let's jump in with Paul and hear why eating nose to tail is so great. Dr. Paul Saladino, we're back.
Brian, it's a pleasure, man. I missed you.
Yeah, it's been 48 hours. It's been a crazy world out on social media land since we got off the last podcast, and I've been posting some inflammatory stuff, some might say, and some might say some very sound science.
It can be both at the same time. You know, this is a disruptive concept. I think that it can be inflammatory in the best way and still be science-based and legitimate. You know, those are not mutually exclusive.
Yeah, it's fun because it pushes us to think about things more, because so many people have come out of the woodwork, and my Instagram and Twitter posts have gone into the vegan world, and they've come and attacked me, and then we start thinking, and then even a listener that agrees with everything we're saying said, hey, what about this podcast I heard with Dr. James Nicolantonio, and he was on Dr. Tro's podcast and he was saying this and that. So let's get into some of this stuff. So we left off with oxalates.
Yeah. So I think that we left off some time about, talking about all the plant toxins. Previously at the last podcast, we sort of talked about the non-need, the non-benefit for fiber in the human diet. We talked about no benefit in colon cancer, no benefit in diverticulosis, potential harm in many of those conditions. And we talked about gut flora and the non-necessity of fiber for a healthy gut microbiome, both in that study, which we kind of broke down and really looked at the details in a granular way. And then we dug into polyphenols a little bit. I know we talked about sulforaphane and the lack of need for sulforaphane. My opinion that there's no need for exogenous hormetics. Well, I should clarify that statement. There's no need for plant hormetics when we're living a radical life. We can mimic many of these plant hormetic effects with just cold and heat stress and exercise. And one of the things I've continually tried to highlight to people is that though the plant molecules, the polyphenols in plants may have a hormetic effect, they often have damaging effects in other areas of the body. And this has been lighting up my Instagram. I was posting about, goitrogens and sulforaphane and isothiocyanates. And I had a number of people on my Instagram over the last couple of days reach out to me and say, hey, I was following Rhonda Patrick and I was eating a ton of broccoli sprouts and I got really sick and my thyroid got messed up. Just today I posted something from a really well-known CrossFitter, and he was saying that he had Hashimoto's thyroiditis and his thyroid got messed up and his testosterone plummeted when he was doing all these brassica vegetables and really following the advice around the Patrick. And then he stopped and things got much better. And so, I called her out on social media and I was like, hey, what's going on here? And I did it respectfully. And I said that I respected her work and that I wanted to dialogue. And then, it's just an interesting thing. It's such a powder keg, but there are plant anti-nutrients that are different from the polyphenols. I would argue that the polyphenols are one of the plant anti-nutrients, but let's dig into some of the other anti-nutrients. And I've talked about this in the past. And usually when I talk about plant anti-nutrients, I lead with this paper from Bruce Ames, which people will know very well if they've heard me on other podcasts. The name of the paper is Dietary Pesticides, 99.99% all natural. And the point that he makes in this paper is that plants have thousands of chemicals that they make. These are endogenous pesticides that are made by the plants. These are not things that are being sprayed on the plants. These are plant molecules. These are endogenous pesticides that are in the plants that are created to deter herbivores and omnivores from eating the plants. And on the second page, there's a really illustrative table that's 49 natural pesticides and metabolites in cabbage. And if we can bring this full circle, many of these are the isothiocyanates, allyl isothiocyanate, 3-methyl thiopropyl isothiocyanate, glucoraphanin is in here, the glucosinolates, the precursors for sulforaphane. So this is an amazingly eye-opening paper. I would recommend that everyone read this paper. It's only a few pages long, but I'll just read a couple of lines from this paper to highlight it for people. So he says, among 1,052 chemicals tested in at least one species in chronic cancer tests, only 52 are naturally occurring plant pesticides, and about half are carcinogenic. So the point he's making there is that we have not tested these plant pesticides for carcinogenicity. And when we do, 50% showed carcinogenicity in the tests. And there are a variety of tests. There are a variety of tests that they can do with these. They can look at the propensity of these compounds to cause chromosomal breaks, which is called clastogenesis. And they can look at the ability of these compounds to form cancers in rodents as well. And the last page of this is particularly eye-opening. And I'll just read a little bit from this so that people have a sense. And he says, there's a study from a gentleman named Ishidate, and I was actually able to get this study and I can talk about it. So he says, Ishidate et al. Reviewed experiments on the clastogenicity, which is the ability to break chromosomes, of 951 chemicals in mammalian cells. Of these 951 chemicals, we identified 72 as natural plant pesticides, and 35, which is 48%, were positive for clastogenicity in at least one test. So what they're saying here is Ishidate did a study of 951 chemicals, 72 were plant pesticides, 48% of those caused chromosomal breaks in at least one test. Now, which ones is he talking about? Allyl isothiocyanate, which is found in cabbage, was clastogenic at a concentration of 0.0005 parts per million, which is about 200,000 times less than the concentration of sinigrin, its glucosinolate, in cabbage. So this is exactly what we see. Just like with sulforaphane, there's a precursor molecule, which is allyl isothiocyanate. Myrosinase combines with allyl isothiocyanate to make synegrin, which is analogous to sulforaphane in this model. And synegrin is in cabbage at a concentration that is much higher than this concentration of allyl isothiocyanate that was able to make chromosomal breaks in these experiments. So hopefully that was a lot of mouthful of words, but basically what they're saying is the compounds in cabbage at levels that are found in food have been found to cause chromosomal breaks in studies like this one from Ishidate. Going further, they say allyl isothiocyanate was among the most potent chemicals in the compendium and is also effective at unusually low levels in transforming and mutating animal cells. Then they go on to talk about safrole, which is one of the compounds in black pepper. Safrole is clastogenic at a concentration of 100 parts per million, which is 30 times less than the concentration in nutmeg and roughly equal to the concentration in black pepper. It boggles the mind. I'll just read a few more sentences. I'm sure this is onerous for people, but caffeic acid, which is found in coffee. This is one of the things I've talked about. I am not a fan of coffee for this reason, among others. Caffeic acid, which is found in coffee, was clastogenic at a concentration of 260 and 500 parts per million, which is less than its concentration in roasted coffee beans and close to its concentration in apples, lettuce, endive, and potato skin. Chlorogenic acid, a precursor of caffeic acid, was clastogenic at a concentration of 150 parts per million, which is 100 times less than its concentration in roasted coffee beans, similar to its concentration in apples, pears, plums, peaches, cherries, and apricots. Chlorogenic acid and caffeic acid are also mutagens. Coffee is genotoxic to mammalian cells. They give a reference there, which people can see in the paper. Plant phenolics, such as caffeic acid, chlorogenic acid, and tannins have been reviewed for their mutagenicity, anti-mutagenicity, clastogenicity, and carcinogenicity here. So that's a lot of big words. I apologize for people if that's painful to their ears. But the point is that these are plant pesticides that are made by the plant. And really what they're looking at here in detail are some of the plant pesticides in brassicas or in cabbage. What we're seeing is, whoa, in experiments, these are breaking chromosomes, and that all sounded very intense. I mean, we probably have the ability to detoxify some of these, but if we don't detoxify these molecules fully, if we do anything to inhibit our liver's ability to detoxify these molecules, then we're going to subject our DNA to breaks. So that's a great paper to start with. I know we don't want to get too much into this stuff, but should we move on to oxalates?
Yeah.
So that is a whole compendium of molecules. Those are endogenous plant pesticides. Now we're going to talk about oxalates, which are something that Sally Norton has talked a lot about. And these are a compound of carbon-based molecules that are found in plants that are also pretty much derived to be defense mechanisms. Now, oxalates are very high in compounds or plant foods like spinach, rhubarb, almonds, kale, sweet potatoes are decently high. And when oxalates come in, we just have to detoxify them. We don't use oxalates for anything in our body. And oxalates are known to form calcium oxalate kidney stones, which is a big deal. I was really impressed at your post today, Brian. You did an awesome post on Sapien about these plant toxins. And one of the studies that you referenced was this study from 2018 in the American Journal of Kidney Disease. The title of the study is priceless. I think that Rhonda Patrick would love this. It says the title of the study is Green Smoothie Cleanse Causing Acute Oxalate Nephropathy. So in the study, they're talking about, oxalate nephropathy. They're talking about oxalate-rich green smoothie juice cleanses prepared from juicing oxalate-rich green leafy vegetables and fruits. So you could put things like spinach and almonds or, spinach and kale or some of these other things into a green smoothie and get a real big oxalate bomb. You can get 800 milligrams of oxalates in one of these smoothies without making any effort. And that is a very toxic load of oxalates for the human body. So an interesting thing to note is that humans do make a small amount of oxalates in the detoxification of some substances that we use in our biochemistry, but otherwise oxalate is not produced in the human body, and it's generally a toxin that we excrete. We probably talked a little bit about vitamin C in the previous podcast, but excess dosing of vitamin C, which I argue against, has been shown to increase oxalates. And if people are B6 deficient, there is a breakdown pathway for hydroxyproline, which is one of the components of collagen, which can result in oxalate. But I really think that only happens when people are B6 deficient, and I don't think anybody's going to get B6 deficient on a carnivore diet. So people on ketogenic diets or carnivorous diets are not going to have many oxalates in their body, but people who are eating green smoothies are going to have tons of these, and they're going to potentially risk joint pain, nephropathy, which is problems with the kidney. There's another article that I've seen that quotes that above the age of 50, I believe, something like 60 to 70% of people have been found to have oxalate crystals in their thyroid. Have you seen this?
I think Sally Norton brought it up.
Yeah, I mean, it's just incredible.
We did a podcast that's unreleased. I don't know when it's going to air, but
all these teasers, man. You're just throwing out the teasers.
Yeah, I know.
So I'm just reading her paper, right? She says the formation of oxalate microcrystals is especially common in human thyroid gland and breast tissue. A study of 182 normal thyroids found that 85% of people over age 50 have calcium oxalate crystals in their thyroid gland. This is coming from bioaccumulation from foods. And if we look at...
And you don't notice it. That's the whole thing. It's like these are older people and they're like, I'm doing fine. I'm like, yeah, I was doing fine. I was drinking kale smoothies and then I started having problems.
And I think this is a fantastic point. Like, look, if somebody's really feeling like they're rocking at life, they're kicking ass, who am I to criticize what they're eating? What we're doing is just trying to put information out there to help people lead healthier lives and have a better quality of life. And we want to make people aware that these could be insidious problems that are not aware of. And we want to help them avoid having them be a problem in the past, in the future. But I think that if people are so close-minded and they're saying, I'm doing fine, I'm not having a problem, it's like, well, you may have a problem in the future. You know, there's a lot of this stuff that kind of comes on.
Just learn about it.
Yeah.
And just know it's all about decision making, knowing the information.
And I'll just mention one more study, which is kind of connected with coffee. Title of the study is Tea and Coffee as the Main Source of Oxalate in Diets of Patients with Kidney Oxalate Stones. So, we analyze the nutritional habits of 22 stone formers with special regard to oxalate as one of the main nutritional lithogenic or kidney stone forming factors. And their dietary oxalate intake was 354 plus or minus 261 milligrams. So, I mean, that's a reasonable amount of oxalate. You could easily get 600 to 700 milligrams of oxalate in one green smoothie. People on Instagram will post pictures of green smoothies, and in that green smoothie is definitely 400 plus milligrams of oxalate. And in this study, they had 22 people who were calcium oxalate stone formers, and their average oxalate intake was around 500 to 600 milligrams of oxalate per day. And the majority of that was coming from tea and coffee. So here's another reason that I'm not a fan of coffee. So oxalates, Sean Baker did a great podcast recently with a gentleman on oxalates. And I think that oxalates are a growing concern and just another one of these plant toxins that we should not ignore if we hope to have optimal health. And sure, we can probably process a little bit of oxalate, a little bit of spinach isn't going to kill us, but at what point does it tip the scale?
Well, it's the seasonality too. It's like we should be eating it year round. It doesn't make sense. Like anything can be poisonous if you eat too much of it. We just need to be mindful of it. And yeah, we should jump into lectins too. I actually just finished The Plant Paradox and Stephen Gundry's, all about lectins. And I had a problem with a lot of his stuff. He's trying to say meat as a condiment.
I can't.
But yeah, I mean lectins, but lectins are
a thing too. The only thing I'll say before we jump into lectins is the idea that we can tolerate a little bit of oxalates, but for people that are sick, I think this is one of the things that I've kind of highlighted before, and I'll continue to kind of say, like, I think everyone should approach this information from the context of where they're at from a health perspective. People that are kicking ass in their life and feeling really good can kind of take a lot of it with a grain of salt and say, hey, I can probably eat a little bit of spinach in my omelet. It's okay. I don't have calcium oxalate kidney stones. I don't have a real joint pain. But if people are sick, if people are not feeling good, if they have depression or anxiety or kidney stones or joint pain or chronic fatigue or, the people that are the sickest are the people that really should pay the most attention, because those are the people for which one of these little details could really be the difference. And that's the people that I think really need to think about doing this type of diet as well as possible to understand how to achieve the best health. For people that are listening, and it just depends. People just, like you said, those guys at the field who are doing the decathlon with you, it also depends, like how optimal do you want to be, and you and I might be kind of obsessive about this and thinking, I don't want any oxalate. If it's going to take me down, I don't want that because I want to feel as good as I can today when I'm hitting the punching bag or being at jujitsu or sleeping, or I want as clear mentation as I can. So I don't want to make this out to be like some scare tactic for people, or that we're telling people that they can't have any more oxalates for the rest of their life. I just want to make people aware and help them put it into a context of how much ass do I want to kick? If I want to kick all the ass, then I need to really hone in on the details. Or if I'm really sick, or you want to kick as much ass as possible, then, you might want to be a little more focused on some of these details. So, but for people that are doing good and are not, concerned about some of these issues, they might be able to pull back a little bit and take it all in context and solve for the highest quality of life at any moment. But lectins are carbohydrate binding proteins found in a variety of foods. They're found in plant foods and animal foods, but they're probably most triggering for us when they're from plant foods. And they seem to be most present in the plant babies, quote unquote, which would be seeds. So seeds, grains, legumes, and nuts are all plant seeds. And the plant seeds seem to have the highest concentration of dietary lectins. There are other lectins in skin of fruits, or skin of vegetables, or roots and stems and leaves as well, but they're all over the place. So, and the other place that they tend to be, some of the more triggering lectins, people, will have heard of like nightshade lectins, things like this. Well, what do we care about lectins? And is there any research to really suggest this is a big deal? And there is. It's pretty wild stuff. It's in its infancy, but I had posted a few things on lectins recently after hearing Paul Mason talk about this and the connections with Parkinsonism. And the idea, there were a series of animal studies that were done in 2016 in C. elegans, which is a worm that has a lot of homology to humans in some, capacity, maybe the neuronal capacity. We use it as a model for some sort of these neurologic diseases. So there's a model of Parkinson's disease in a C. elegans worm. And what they found was that they were able to observe transit of dietary lectins in the worm's diet from the gut of the worm to the brain of the worm through the vagus nerve. And this is just so wild, this concept that they could move through the vagus nerve, and they could do this in humans as well, and that lectins from our gut could move through the vagus nerve to the brain and affect dopaminergic signaling. And so the conclusion here is these observations suggest that dietary plant lectins are transported to and affect dopaminergic neurons in C. elegans, which support the hypothesis that suggests that one alternative potential dietary etiology of Parkinson's may be through this lectin mechanism. And they also note here, which is another study, that a recent Danish study showed that vagotomy, which is severing of the vagus nerve, this is in humans now. There was a study in humans that showed that vagotomy, so severing the vagus nerve, resulted in a 40% lower incidence of Parkinson's disease over 20 years. Differences in inherited sugar structures of gut and neuronal cell surfaces may make some individuals more susceptible to this conceptual disease etiology model. So what are we talking about here? We're talking about the fact that in worms and in mice, the lectins can get transported to the brain, and then they're paralleling that with observational studies in humans who have had vagotomy. That the observational studies in humans with vagotomy show that the humans with vagotomy have a 40% lower incidence of Parkinson's disease over 20 years, suggesting that the same mechanism might be in play in humans. There's another study on the lectins that I can pull up in mice and rats that's pretty similar. But basically what happens with the lectins is that in these studies, they will add some sort of lectin, whether it's a nightshade lectin or one of these other lectins. They'll do something to irritate the gut. And the combination of those two things will cause the lectin to get taken up through the leaky gut, transported through the vagus nerve, and then end up in the brain of these animals. And then potentially, and then the other thing they're seeing is it actually affects the signaling in the brain of these animals. It's just so wild to think, holy moly, like that is crazy. Isn't that a scary thought?
Yeah. We're learning so much about the gut and the brain connection. And it's so weird because every vegan that's talked to me lately, and I always ask vegans, will you come on the podcast and let's talk about this? Because I can never get it across in little messages. And they all say, I have anxiety, I don't want to come on. they all have some sort of like mental thing going on. I mean, is this just confirmation bias?
Could be. I don't know. I mean, I think that observationally, I would argue that psychiatric disease is autoimmune. I've said that before. That's not radical at this point for me. But I think that, I think there's a hypothesis now, which perhaps a little bit premature, that, vegan diets, vegetable-based, plant-based diets could be inducing autoimmunity in people. And those could definitely be connected with worsening anxiety. I've certainly seen anecdotes online. People say, my anxiety got so much worse when I did a vegan diet. And what can we draw from that? Well, we can draw a hypothesis. We can't draw a full conclusion just yet. But we worry that lectins in plant molecules could be one of the things that are, number one, irritating the gut lining, causing leaky gut, triggering the immune system. Number two, actually physically moving through the body in the vagus nerve into the brain and causing an immunologic reaction there. We've talked about activated microglial cells, these brain-derived macrophages in the past, and it's totally plausible that there could be some of that at play in Parkinson's disease around the dopaminergic neurons. So that's just one of these other things that is really scary in that context. So far we've talked about the endogenous plant pesticides and the Ames paper. We talked about oxalates. We can talk about phytic acid. Phytic acid is one of these plant anti-nutrients. It's a large molecule which chelates divalent cations, calcium, magnesium, zinc, phosphorus in plants. And when we eat that, it can chelate the same things in us. So anyone that talks about levels of magnesium or calcium or zinc in plants, that discussion must always be tempered with the knowledge that those are not very bioavailable because of the phytic acid, because of the fact that the phytic acid will build up, or it chelates those molecules in the plant and it can chelate the molecules in us. So I would argue that mineral deficiency will develop or can develop very rapidly in people on plant-based diets because of the phytic acid. And there's just the nutrients are not bioavailable. I mean, you did this awesome post on Instagram about the bioavailability of nutrients in animals versus plant foods. And on your, on Sapien, you have an illustration of that and some really great articles talking about how bioavailable animal nutrients are and how not bioavailable plant nutrients are. And one of the reasons plant nutrients are not bioavailable is because of phytic acid. So it's a really big deal. And I think that it's causing problems. I'll just add in a little story about what I believe is phytic acid in my life. So I previously was an ultra runner. I got into ultra marathon running when I was in college and then after college. And I was eating a ton of oatmeal. And if people know about oats are one of the highest phytic acid foods on the planet. And the phytic acid is very difficult to break down. So soy is also very high in phytic acid. And phytic acid is not denatured with heat. It's only denatured with fermentation because of the phytase enzyme produced by the bacteria. So I was eating a ton of oatmeal and I was running a bunch. I was in the carb world and I got recurrent stress fractures that were just time after time after time. I had some horrible stress fractures when I was in college. I stress fractured my femur, which is an unusual bone to stress fracture. And then I went paleo. And when I took out the grains, I really believe that when I took out the phytic acid, I was able to run twice as far. I was running 80 to 100 miles a week at one point with no problems with stress fractures. So for my history, I really believe phytic acid played a large role in the lack of bone health that I had as a young man in my running career. And I was never a very superlative runner by any stretch of the imagination, but it was super frustrating to not be able to run for months at a time with these stress fractures. And I found personally that when I eliminated phytic acid by eliminating all the grains, that I had a much better ability to run, at least from a stress fracture perspective. Again, we're kind of getting back to the issue around polyphenols. We can go back and cite a few specific compounds in plants that I think are remarkable. We talked about sulforaphane. I want to highlight a molecule called canavanine, which is found in alfalfa sprouts. The seeds are the most highly defended part of a plant, and that sprouts are probably the second most highly defended part of a plant. Canavanine is present in alfalfa sprouts, and it's been shown in monkeys to induce a lupus-like state. It's incorporated into proteins in the place of arginine, and it can cause the monkey lupus. And I think that there's never been a study for this in humans, but it looks just like human lupus. These monkeys get positive ANA, which is anti-nuclear antibodies, just like we do in humans. That's how we diagnose one of the markers we use to diagnose lupus in humans is anti-nuclear antibodies. And we see the same thing in monkeys, that it can cause this lupus-like syndrome. It's probably getting incorporated into proteins in place of arginine and causing some sort of immunologic reaction. So just another one, there's a compound in white button mushrooms, which includes portobello and cremini, called agaritine, which is frankly toxic. We've talked in the past about cyanogenic glycosides. I believe in the last episode we talked about linamarin, which is a cyanogenic glycoside found in cassava, and all of these things like that.
What about resveratrol? Speaking of wine, people think it's so great.
Oh yeah, let's talk about resveratrol a little bit. So, this discussion can get long, but resveratrol is interesting. I know David Sinclair was recently on Joe Rogan talking about resveratrol. Resveratrol is a polyphenol, but it appears to have benefit a little bit differently than other polyphenols. Resveratrol actually appears to trigger the sirtuin family of genes, specifically, I believe, SIRT1 and maybe SIRT3. And what we see in that is that those are kind of longevity genes. Those genes use NAD to do processes in the human body, and they're involved in longevity. We know that when those genes get turned on, it's generally a good thing. They're kind of cellular sensing mechanisms. They use NAD to make nicotinamide and ADP ribose and things like this, and it's part of the functions of the sirtuin genes. And so the sirtuin genes are interesting because they get turned on during low nutrient times. So we can also turn on the sirtuin genes with fasting and ketosis, but the sirtuin genes are one of the things that are turned on during caloric restriction. So it's kind of like we can use this molecule resveratrol to mimic caloric restriction, at least at the level of NAD and NADH and the sirtuin activities. And we can also do that by actually fasting or actually achieving caloric restriction. And so they've done studies in mice with the sirtuins and resveratrol, which are fairly compelling, that suggests that when they make mice very fat, they have two groups of mice. One group is fed a regular diet, one group is fed a diet that's 60% soybean oil. And you can imagine that the soybean oil group gets really fat and they get fatty liver and they get kind of like mouse diabetes. And when they feed that group of mice resveratrol, they kind of normalize. They look more like the mice that are fed the regular diet. So they're saying, look, this is a fountain of youth, right? This is a panacea. We can feed resveratrol to people and they can still eat donuts, right? It's perfect. The problem with this is just like the other plant molecules, and this is the pattern that I began to see with plant molecules, is that just like sulforaphane, we can, if we just look under a spotlight and we say, look, they're improving the way the sirtuin genes work, or they're turning sirtuins on. Okay, yeah, sulforaphane does a similar thing. It turns on NRF2 and it can increase glutathione. But if we look at the whole body, if we look elsewhere in the human body, that's where the badness with things like resveratrol and sulforaphane, as we talked about last time, start to be more evident. I think that because people are selling these supplements, they don't tell you about this and it's not really known. But, it's not in the interest of people selling things like sulforaphane or, any of these resveratrol or these compounds that are supposed to activate the sirtuins, to note that if you look at other places in the body, what is this molecule doing? That's the question that I'm always asking now with these plant molecules is, what is this molecule doing elsewhere in the body? Sure, it's going to turn on the sirtuin family of genes. Is that the only thing it's doing? Because it's from a different operating system, and I have a suspicion that it's going to interfere with human biochemistry or immunology in another way somewhere else. So an article that's never talked about, certainly wasn't talked about by David Sinclair on Joe Rogan, is from 2015. It's a placebo-controlled, randomized clinical trial, high-dose resveratrol treatment for non-alcoholic fatty liver disease. And what they saw in this one was not only a lack of effect. So the conclusion is, in this placebo-controlled, high-dose, long-term study, resveratrol treatment had no consistent therapeutic effect in alleviating clinical or histological NAFLD, which is non-alcoholic fatty liver disease. And so this study failed to show any benefit. And, that's okay. Maybe NAFLD is not the best place that we're going to see a benefit, although in mice, it did look like it improved the liver stuff, but in humans, it didn't. But what they noted in this study was that one of the participants, there were 28 participants in this study, and I think one or two of them developed some pretty severe autoimmune symptoms with this dose of resveratrol. I think one or two of them developed pretty severe thrombocytopenia. Thrombocytopenia is when the platelets go very low, and there's a type of thrombocytopenia called autoimmune thrombocytopenia. And so this brings up the problem with resveratrol, which I haven't talked about much and isn't really talked about much in general, that in addition to activating the sirtuin family of genes, it's doing other things. And one of the things that it seems to also be doing is affecting the immune system, potentially in very negative ways, potentially triggering autoimmunity. It's been shown to cause changes in the way that T helper 17 cells are being populated in the human body. And that can be, when we start messing with the immune system, we're starting to say, oh, maybe this isn't the good thing anymore. And I would argue that that could definitely be part of the mechanism behind this thrombocytopenia in this other study. I mean, there were only 30 patients in the study, and at least one of them developed a fairly severe complication with this resveratrol that appears to be an immunologic mechanism. And so the concern begins to be like, hey, why are you taking a molecule to turn on sirtuin genes when you could just be fasting or, doing a ketogenic diet? Like, it's the same as sulforaphane. It's completely analogous. These mechanisms are not unique. It's not like there's no other way to turn on the sirtuin genes. We know that fasting and ketosis will increase your NAD. These are essentially caloric restriction mimetic drugs. Why don't we just do that instead of using a plant molecule with all of its attendant negative side effects on the side, which nobody's really focusing on? These are foreign molecules to the human body. They're doing other bad things elsewhere. They're mucking up our biochemistry. So does that kind of make sense?
Yeah, absolutely. I mean, people get excited about doing this research, and I could see how they're just ignoring some of these things. But it's also funny that ketosis and fasting have so many other great benefits as well.
Yeah, I mean, I think that people want to have great hope for these molecules, and I don't mean to just go around pissing on everyone's campfire. I just want to say, hey, maybe this isn't the best thing. The plants didn't design this compound for us. If it ends up to be beneficial, it's an incredible, evolutionary accident. There's no reason that the plant should make a compound that's beneficial for us. This is not a vitamin, right? These are plant polyphenols that have a role in the plant. And if it's an accident, if it has any benefit to a human. And so we say, oh, we found this molecule that accidentally does this. And we get all excited. And then there's millions of dollars or hundreds of millions of dollars pumped into the research, which is fantastic. But we really need to be careful and we need to remember that, man, like these molecules the pattern that I continue to see is these molecules are not without negative side effects, and none of the molecules have unique effects on the human body that we cannot achieve by living what I would say is a radical life. I've started saying that a lot recently. If you just lead a radical life, you can do all these things without any of the side effects.
Yeah, that's funny. Well, there's no free lunches in nature. I love that quote where you can't just expect to just take some magical thing and then you can just eat donuts. And the same thing, I was going to ask about people injecting NAD or people injecting glutathione. It's like, it doesn't seem like that is going to work.
It's a horrible idea.
Either, right?
Horrible idea.
Right? It's the same thing as injecting testosterone or HGH. Your body's going to downregulate your ability to make it yourself.
Yeah, the testosterone and HGH thing is a little bit complicated, but the NAD and glutathione thing is a little more straightforward. I love what you're saying there. There's no free lunch in nature. And, I'll just say it. I think that the thing that I like about this space is our ability to dialogue, and I want to be respectful of Rhonda Patrick and respectful of David Sinclair, but I also want to call them out. David Sinclair is on Joe Rogan and he's saying, hey, I was pre-diabetic, so I started taking metformin, and I'm thinking, dude, you're pre-diabetic. Like, you're a researcher doing research on resveratrol and you're pre-diabetic. Does it not strike you that like you need to change your diet? Like, why are you taking metformin? That doesn't make any sense.
He started years ago. I think he said like 20 years ago he started.
Well, and he took it because he's pre-diabetic. And that's a whole other discussion about metformin and longevity and Mtor, which we can get into. But it doesn't make any sense to me. And Peter Attia had a guy on his podcast too, who is a big researcher for metformin in the TAME trial, I believe. And that gentleman was also on metformin because he was pre-diabetic. And I'm thinking, have we lost the forest for the trees? I mean, I greatly respect Peter Attia, and I greatly respect, I believe that researcher's name, I'll butcher his name, I won't even say it. It's the TAME study researcher. But, I greatly respect their work, but it's like, what are you doing? Like, you're pre-diabetic. There's this insidious, like, undercurrent. Like, yeah, the goal is to be able to eat donuts and live forever. Like, what? Why don't we just live a radical life and live forever? Like, there's no free lunch. We're not going to be able to do that, but we're gonna run around for the next 50 to 60 years, and people are going to make $1 million. People are going to make $1 million and call it biohacking with all of these molecules that are not going to actually do anything for us in the long run, and that are going to potentially cause harm, when really we just have to admit that we're trying to hack something that we shouldn't be messing with. I mean, I think we should not stop doing anti-aging research, but all of this, I mean, we're putting it under the moniker of biohacking right now. And I agree with you completely. It's just about eating donuts and wanting to live forever at the same time. People want to have their cake and eat it too. They want to be fat mice and take resveratrol and then be normal mice. And it's like, why not just be a normal mice? I mean, we know how to do that. And that brings with it other quality things. Live a radical life, do some fasting, go out in nature, do a hard run, jump in cold water, go in a sauna, climb a mountain, get plenty of sleep, exercise. Yeah. Like, you can achieve all of the same things as these molecules without any of the bad side effects. It doesn't make any sense to me.
I love that. I love that this is your big thesis. It's like Gary Taubes has his thing against sugar, and everyone has their big thing. And I love your thing. It's just, we don't need these plant foods. It's like some people just do carnivore. They're just like, oh, I just do it because it's like I lost weight. But you're like, no, there's actual reasons why this works. Yeah.
And we talked about the studies last time that show that 1.5 pounds fruit and vegetables a day for a week, 4 weeks, 10 weeks, no benefit on the antioxidant system in the human body, and I think that the problem with a lot of these studies with whatever molecule du jour it is, whether it's urolithin or astaxanthin or resveratrol or sulforaphane, is that we don't have an event horizon and there's no outcome studies. There's never been a study with any of those molecules that says, hey, we gave resveratrol to people for 80 years. And guess what? They look like they're 70 years old, or they look like they're 60 years old. Or, there's never been a study. There's never been a study with humans that says, hey, we gave resveratrol to these people for 80 years, and the resveratrol group had a really clear increase in longevity. That study will probably never be done, or it'll be done over the next 80 years with everybody taking resveratrol. And I fear that it will fail miserably. And then in 80 years, we'll figure it out, but that's a tragedy. We can't do the studies. There's no way to prove this, which is the problem, is that people can get up and say, you should take resveratrol. And it just strikes me as like, wait a minute, why are we taking this molecule that doesn't have a unique mechanism that I can achieve with ketosis or fasting? And then it's also been shown to cause autoimmunity. Do I really want to mess with my immune system like this? And you're right. My premise is becoming that these plant molecules are from a different operating system. And if we look, we will invariably find dangerous things with these plant molecules. It's just like giving any pharmaceutical molecule. We know pharmaceutical molecules have side effects. I don't know why we are so slow to admit or accept the fact that these plant molecules have side effects. And no one wants to focus on the side effect. When I give a drug to someone, whether it's an antidepressant drug or a blood pressure drug or a cholesterol lowering drug, I'm giving them a molecule. Whether that molecule is simvastatin or fluoxetine or mirtazapine or amlodipine, I know that molecule is going to have side effects. It's going to do one thing and it's going to do a bunch of other stuff on the side. But with these plant molecules like sulforaphane and resveratrol, we're so willing to believe that it just does one good thing, when in fact it does one good thing plus 6 other side effects that no one wants to talk about because they're selling it because it's a $30 million industry, right? And that's what drives me crazy is like, yeah, resveratrol might do one good thing, but it's going to have side effects. This is just like a pharmaceutical molecule because it's a foreign molecule. It's not from our operating system. And so I hope that makes sense to people, that these are plant molecule side effects, just like we would get side effects from a drug. There's no physician that prescribes a drug. Every physician on the planet, every physician listening to this knows that there is no drug without side effects. Zero. You give a human a molecule that is not part of their regular biochemistry, that molecule is going to have side effects. Some of those side effects are really bad, depending on the medication. I give someone the molecule olanzapine, which is an antipsychotic. They get metabolic syndrome, they get diabetes, they get really fat, and it's a really tough decision to make. Right? That is a very bad side effect from that molecule. Some of the side effects are less bad, fluoxetine, selective serotonin reuptake inhibitors. These are less bad side effects, but they're still side effects, And this is the thing that's going on with these plant molecules. They have side effects. These are pharmaceutical drugs. We need to treat them and think about them as pharmaceutical drugs. And remember, are we treating the root cause of the problem, or are we just ameliorating the symptoms? And is it worth the side effects for what we're doing? And every person has to answer that individually. But as we're saying, you can also get all of these effects of these drugs by just living a good life.
And another thing that's really related is we have enough of these hormetic stressors. People are thinking, oh, it's good to have these different stressors, but we have enough in our modern environment. We have like polluted air, or like the water is not the same, like all these other things going on.
That harkens back to the study that I've mentioned previously about the cold swimmers in Berlin, this idea that there are plenty of hormetic stressors in our environment, whether they're toxic hormetic stressors or hormetic stressors just from cold or heat or exercise. We don't need these molecules for hormesis. We don't need it. And when we look at the interventional trials with vegetables, they have no added benefit. And then they come with all these plant toxins that we've been talking about. So, and like we're enumerating, the plant toxins they're huge. They're all over the place. And there's phytohemagglutinins, there's sorolins, there's phytoalexins. It's just, we could go on and on. So I think we've covered a lot of the plant toxins by now.
Well, yeah, I was going to move on to a meat toxin because I've always wondered about this as carcinogens and people charring meat and, heterocyclic amines or something. Like I've always thought that we've been charring meat for millions of years when we invented fire, maybe 2 million years ago. So we've either figured out how to deal with these, or that these are a good hormetic stress, then that's all we need.
This is a really interesting point, Brian, and you are so on the money, my friend. I mentioned earlier that sulforaphane activates the NRF2 system in the liver, and that results in increased amounts of glutathione. Well, polycyclic aromatic hydrocarbons and heterocyclic amines activate the same system in the liver. So essentially, if you think sulforaphane is a hormetic, then you have to classify polycyclic aromatic hydrocarbons and heterocyclic amines as a hormetic stressor as well, because it does the same thing. And, I think that like any hormetic stressor, there is a dose response curve, and it's a J-shaped curve, meaning that, or a U-shaped curve, meaning that there is a sweet spot, and our body, I think that there's evidence that our body can deal with some of these polycyclic aromatic hydrocarbons. Absolutely. And if we overload the body's ability to detoxify the polycyclic aromatic hydrocarbons, I think that they are carcinogenic, and it can be a factor. And in the case of sulforaphane, don't do any of it at all. So there's a great study, heterocyclic aromatic amine intake increases colorectal adenoma risk, findings from a prospective European cohort. The title sounds damning, but if you dig into it, I'll put the details out there for people. American Journal of Clinical Nutrition. And they show that only in the highest amounts of extremely browned meat. So they said the adenoma risk was only increased with the consumption of strongly or extremely browned meat. And there was no statistically significant increase for lower amounts of polycyclic aromatic hydrocarbons and heterocyclic amines. So basically, the reason the study is interesting is because they're saying, okay, if we have a continuum of like browning ground beef, and you just, people have made ground beef, they know that you can like cook the shit out of it and make it like super, brown. And there's a trend there. There's going to be more of the PAH, more of the polycyclic aromatic hydrocarbons and heterocyclic amines in the very seared meat. So what I would say is, based on the research that I've seen, like this one, the polycyclic aromatic hydrocarbons, heterocyclic amines are only connected with cancer when they're in their highest doses. So like you said, and I've talked about this before, just mitigate it. Just think about the way you're cooking your meat. Don't cook the shit out of your meat, because your meat is going to taste good anyway, but don't eat meat that's burned. Don't eat, meat that you overcook. Don't eat extremely ground beef all day, every day. And I would agree with your suggestion at the beginning of this discussion that absolutely humans have processes by which we deal with these molecules. And they, in fact, are hormetic processes, which is incredibly interesting, because there's no one selling polycyclic aromatic hydrocarbons for $30 million a year, right? But there's a sulforaphane industry for $30 million a year. And in some ways, they are similar, at least in what they do in our liver. So that's a pretty wild thing. The other thing that I'll highlight here that I think always has to go hand in hand, just to really consider both sides of this equation, is that there are plenty of carcinogenic compounds formed in the cooking of plants, like acrylamide and advanced glycation end products. The latter, advanced glycation end products, are not necessarily carcinogenic, but they are damaging. And AGEs AGEs can be formed with both meat and plants, and we can talk about AGEs. But I do want to talk about acrylamide. Acrylamide is only formed in the cooking of plant foods, and acrylamide is one of the things that is on coffee. So the study is Dietary Acrylamide and the Risks of Developing Cancer, Facts to Ponder. It's formed when you brown or burn plant foods. So every piece of toast, every bagel, every coffee bean that's browned and roasted has acrylamide. It's present on croissants and breads, and everything that's browned has acrylamide. And so this is a known carcinogen. So, the plant-based people never get hit with this, what about acrylamide? They always say, what about the toxins in meat when you cook it? Well, yes, and we can deal with it. And there's acrylamide, which we can probably detoxify some acrylamide too, but we don't want to exceed our ability to detoxify it. But I'm just saying, it's our cumulative load, right? And one of the benefits that I see to limiting exposure is I want to limit my exposure to these compounds as much as possible. I don't, even though I know that polycyclic aromatic hydrocarbons have some sort of a hormetic effect, I don't try and consume them. I cook my meat as little as possible. I try and do sous vide or do crock pot when I can. And so I'm limiting it. But, cutting out coffee would be beneficial from the caffeic acid, chlorogenic acid perspective that we had talked about previously. And it's going to limit your exposure to acrylamide as well. You cannot drink coffee without getting acrylamide in your coffee. So that's a big deal. And people never talk about that with plants, that there are plant compounds that are similarly carcinogenic and very concerning.
I'm going to come in again as a devil's advocate and say at some point you got to figure out what kind of life you want to live and minimize your risks. And if you need your coffee, some people are like, life's not worth living without my coffee. So it's like, have your coffee, but maybe you need to just be careful with everything else.
Or just know that people are not convinced that your coffee is necessarily good for you. And if life is, and like I said earlier, I've kind of hinted at this and I haven't really expounded on it, but I think that people should solve for the highest quality of life at any moment in their life. And if coffee is absolutely something that makes life worth living for you, then drink your coffee. But if you're sick and you are willing to cut out coffee, I would argue that some people might find a real benefit in that process. And that's something that I recommend to a lot of people. Like, how do you feel without coffee? How do you feel without caffeine? I think that's worth exploring. And I think we should probably touch on advanced glycation end products for a moment here, because I think it's an issue, in both worlds. There are dangers to living a carnivorous lifestyle. There are dangers to eating meat. Polycyclic aromatic hydrocarbons, as we talked about, are a thing, and advanced glycation end products are a thing. Advanced glycation end products happen when we cook meat, and they happen when we cook plants. The foods that have the highest amount of advanced glycation end products are some of the foods that people like the most. So this will probably cause a tear or two to be shed. So in the animal world, there are bacon and butter are the highest in advanced glycation end products. And there's pretty good data to suggest that higher levels of AGEs in the diet are problematic and are associated with higher incidence of things like insulin resistance and diabetes. Now, one of the interesting things about an animal-based diet is that you're going to get a lot of carnosine. You're not going to get much carnosine on a plant-based diet, but carnosine, not to be confused with carnitine, carnosine, which is only available in animal foods, has been shown to help mitigate some of the damage caused by advanced glycation end products. The other thing I would recommend is, limit your consumption of bacon, or just take it into your quality of life equation. A lot of people on carnivore diets, I see they're just eating bacon at every meal. And I'm like, yeah, that's delicious, but that's a lot of advanced glycation end products. If you look up the data, if you look at the AGE studies, the units on AGEs are just like an arbitrary advanced glycation end product unit, but butter is like 30,000 per, I forget, maybe gram, and bacon is like 85,000 per gram, which is the highest of anything. And the idea is that the advanced glycation end products are going to form on a compound when you cook it in its own fat. It kind of that high temperature of fat cooking. And unfortunately, it makes things that we like as humans. We like that crispy bacon. The more crispy it is, the more advanced glycation end products there are. And people might say, I don't care, I'm going to eat my AGEs. And I say, that's great. I just want to tell you about it. You do you. It doesn't matter. It's just,
well, you can bake it. I put bacon in the oven and you don't have to make it super crispy. I don't eat it all the time.
Yeah, you could do that. Or, you could just not eat bacon every day, or, I recommend to a lot of people that they avoid dairy during a carnivore diet to see if they have an immunologic reaction. But yeah, butter and bacon are the highest foods, but I'm not a huge fan of cooking bacon in its grease for a long amount of time. And when I talk to my clients, I also say, hey, don't cook your steak in tallow. Like that's just going to make more AGEs on the steak. And it gives it this nice, like fried, you get a fried steak, but
a little crispy.
Yeah, it tastes good, but that's not good for longevity. And I think that we just need to be aware. Like, I just want to make people aware of how to improve this or that, and people can make their own decisions about quality of life. I mean, that's delicious and maybe not great for longevity. So you tell me what you're going for and we can adjust it accordingly. But I think that it's important to note that animal foods intrinsically don't come with toxins like that. It's just how we prepare them, and we can totally mitigate them. You can eat a very nutrient-rich animal-based diet without any of these issues being a factor, or you can eat an animal-based diet and you can have more of these issues. So it's going to come up in conversations. I want people to be aware of how they're formed and how to mitigate them.
Can I jump in with the animal toxins? Because one of my many vegan naysayers was saying that I was insane for thinking that meat didn't have toxins, that it collects in their fat.
Yeah. This is not an endogenous meat toxin. It's something that we have put into the environment. So, I mean, it's not in the meat itself. It's not in the animal. It's the fact that humans have polluted the environment. So, I mean, I don't know what to say about that. I mean, that's in everything on the planet. I mean, you can't avoid that. You have to eat something. And I think if a vegan believes they are getting less toxins or they're getting less persistent organic pollutants because they're not eating animals, they're severely mistaken. I mean, yes, it could bioaccumulate in the animals, and I think it's a strong argument for eating the cleanest animals that you can, the most sustainably raised, the most ethically raised animals. I would argue for grass-fed and as clean as possible, but that's all you can do. I mean, I think that what are we supposed to do within our framework? We're supposed to eat a nutrient-poor diet and get chronic disease so we don't get persistent organic pollutants. I mean, ultimately what we're trying to do is create the healthiest human population. And I would argue that there's a clear winner in the animal-based realm. Yeah, we're going to get some persistent organic pollutants from the things that humans have put in the environment. But man, like, I think that pales in comparison to the plant toxins, the plant endocrine disruptors.
We didn't even talk about what's sprayed on the plants or what else we're getting.
Yeah, I mean, we know this is a big deal. And I mean, unfortunately, it's going to be in our animal meats as well, because, depending if the animal meat is organic, presumably we're going to be able to avoid the glyphosate. But, organic plant foods will have less. But, non-organic plant foods are sprayed with glyphosate or Duo, which is a combination of glyphosate and I believe it's, I'm going to mess it up. It's one of the components of DDT. It's another pesticide. And there's a lot of concern now between Stephanie Seneff and some of these other researchers around glyphosate doing all sorts of problems, interrupting. We know that it interrupts bacterial folate pathways and the shikimate pathway. We know that it's been shown in cell culture to disrupt the epithelial lining of the gut and cause leaky gut. I mean, it's not a good thing to be eating. And so that's all over plants. And this is another argument to eat, a very well pastured animal or an organic animal and or organic plants if we're going to be plants. But yeah, glyphosate is not something to ignore. It's not something people should ignore in that respect at all.
We're talking about longevity. Let's keep that going with mTOR and IGF-1. We kind of teased that last episode.
Yeah. So the longevity piece, is super interesting. And I think that the discussions of sulforaphane, resveratrol, these are the discussions of people who care about longevity. And we were talking about advanced glycation end products. And we were talking about, I think the people who are worrying about this are interested in longevity. And I think that longevity is sort of a two-pronged discussion. Not only do we want to live long, we want to live well. That's what we see in hunter-gatherer populations is they generally have quite good function up until the very end of their life. Their functionality curve is much different than a westernized human. If you were to draw the curve of, how functional, what's the quality of life of a westernized human, it would sort of be this gradual decline from age 30 on down. But if you look at like a hunter-gatherer, it's really high their whole life, and then it drops off in the very end of their life, maybe the last month or weeks of their life, but they're quite vital up until the very end. And that's the goal, right? And so all the discussions about carnivore diets, about animal-based diets run into this issue of mTOR because people get worried and they say, oh, aren't you going to overactivate mTOR? mTOR is mammalian target of rapamycin. It's a kinase. It is involved in anabolic processes in the human body. In a very overly simplistic model, it's balanced by AMP kinase or AMP kinase, which is sort of a catabolic enzyme. And these two processes are kind of balanced. And the mammalian target of rapamycin is just like it sounds. There's a drug called rapamycin, which has been found. There's an incredible story of rapamycin and its discovery on Easter Island. It's named after Rapa Nui, which is Easter Island's name. And it's from a fungus, and it's a molecule that inhibits mTOR. And it's been found in some animal trials to prolong life. And so people think, oh, this is great. We should just stop mTOR and we'll live forever. And again, this is kind of that I want to eat a donut and live forever with the six-pack mentality, in my opinion. But, if we look at mTOR is vital for life. If we don't have the mammalian target of rapamycin, we can't do anything anabolic. We can't grow. We can't build muscle. We can't do any of these things. And I think that most people realize that a balanced life is going to have some cycling between mTOR and AMP kinase. It's going to have catabolism and anabolism, anabolism, catabolism and anabolism. It's going to be catabolic and anabolic at different times. And so you don't always want to be catabolic, you don't always want to be activating AMP kinase. You do want to activate mTOR sometimes. It's just a question of how often you want to activate mTOR. And so it's so funny because, in my world, as a physician interested in animal-based diets for health and longevity, I get people on both sides of the coin kind of challenging me. On one hand, I'll get people who are interested in longevity saying, aren't you going to overactivate mTOR because you're eating all this protein? And, this is a very interesting discussion. Hat tip to Ben Beekman, who I've had discussions with us about. There are two things that activate mTOR. One of them is leucine, which is one of the branched chain amino acids, and one of them is insulin. And there are a couple of studies that compare the relative effects of leucine and insulin on mTOR. And what they found was that when you eat leucine, like you might on a carnivorous diet, you're going to get a big dose of leucine in your steak, you do activate mTOR, but it's a pretty transient activation of mTOR, maybe 30 to 40 minutes, at least in the experimental model that was studied. When you activate mTOR with insulin, it's a much stronger activation of mTOR through a different mechanism, and it lasts for 3 to 4 hours. So if people are eating, clearly what is activating mTOR is carbohydrates, right? Or insulin, not protein, relatively speaking. I mean, we have to eat both, right? You don't have to eat carbohydrates, but you have to eat protein. So we have to activate mTOR at some point during the day. Unless you're completely fasting, in which case you are just going to be straight AMP kinase, and everyone knows what happens with that. You are sort of gradually, you're doing so much autophagy, and if you don't stop, you will die, So we can't do that. So we have to activate mTOR in the day. We have to eat either protein or carbohydrate or both. And I would argue that there's pretty clear experimental data that insulin is activating mTOR much more robustly and for a much longer amount of time than protein, than leucine. And so, for instance, on a carnivore diet, like today, I ate twice a day. I'll eat 2 decently sized meals with steak. And I've talked about my diet previously, and I can talk later in the show about what I eat exactly. But my meals today were like, grass-fed steak with a little bit of tallow and bone marrow and salmon roe and whatever. So I had some leucine. There was a leucine load. I probably had plenty of leucine and activated mTOR, but then my mTOR goes off after 30 to 40 minutes. So I had one episode in the morning, 30 to 40 minutes, maybe an hour, mTOR's on. Then I don't eat anything for 4 or 5 or 6 hours. And then, maybe a little later in the day, I'll eat my second meal of the day. mTOR's on, then it's off, right? Let's compare that to if I'm eating 3 meals a day or even 2 meals a day of insulinogenic foods. Like say I had a normal breakfast, whether it's a sweet potato or, an apple or an orange or whatever I'm going to eat with carbohydrates, maybe some grapes or something, any sort of carbohydrate, I'm going to push insulin up. And that insulin is going to activate mTOR for 3 to 4 hours. And then I'm going to eat again at lunch, another 3 to 4 hours. And then I'm going to eat again at dinner, another 3 to 4 hours. Somebody that's eating a carbohydrate-based diet is going to activate mTOR for 12 plus hours a day. I would argue that on a meat-based diet or a carnivorous diet or an animal-based diet, you're going to activate mTOR for maybe 2 hours a day at separate windows. So there's really no comparison in terms of mTOR activation here, right? Like it's completely different. I'm activating it a few times, but I'm not activating it all the time. And so people will say like, I heard this I heard, I know we've referred to this podcast with Tro and James Nicolantonio. Yeah. And, in that podcast, James Nicolantonio was saying, I don't want to activate mTOR with protein. So I'm going to do some protein sparing eating, and I'm going to eat, some carbohydrates. And I'm thinking, no, you're completely missing the point. Like, there's no point in sparing protein for mTOR activation. What you really should be doing is sparing carbohydrates, do some carbohydrate sparing. Everybody talks about a protein sparing fast, right? Like, or protein sparing. What we really should be talking about is carbohydrate sparing fasts, which is, what we're doing every day on a carnivorous diet. So clearly mTOR is activated by protein, but to a much less extent. And I'm happy to provide those references if people want to see them.
But yeah, they also brought up in that podcast their new book with Dr. Jason Fung and James Nicolantonio was talking about 50-50 plants and animal foods.
Yeah. So the title of that study, people can see it in the show notes, will be The Actions of Exogenous Leucine on mTOR Signaling and Amino Acid Transporters in Human Myotubes. That's probably the best one to refer to. Before we get to the hunter-gatherers and the composition of foods, I just want to talk about the other side of the story, because I always get both sides of the story with mTOR. It's so funny. You get hit from both sides. People will say, hey, I want to activate mTOR. How do I gain muscle on a carnivore diet? I'm thinking, oh my gosh, this is so funny. The longevity guys don't want to activate mTOR. And these CrossFit guys and these bodybuilders, all they want to do is activate mTOR. So, I kind of have to say the same thing to them. Like, if you want to activate mTOR on a carnivore diet, then eat meat throughout the day. You can definitely get an anabolic signal on a carnivorous diet. So if people are CrossFitters or whatever, and they want anabolic signal, all you have to do is eat leucine. You don't have to eat insulin, and you can activate it. So if somebody were doing that, they could eat some meat or some protein, 5 or 6 times a day, and you're going to turn on mTOR all throughout the day, or, in line with your training. So you can leverage it however you want. You can do both sides of the coin, or if people were doing CrossFit or bodybuilding and they wanted to leverage and they wanted to do a carnivore diet because they had an autoimmune issue or they felt better with it, you could do something that triggers insulin on a carnivore diet. You could do something like honey, which would spike your insulin on a carnivore diet. And so you can get insulin on a carnivore diet. I think at that point, we're basically splitting hairs, but yeah. But I just wanted to add that in because people always ask, like, how do I gain weight on a carnivore diet? And they say, do I have to eat rice? Do I have to eat carbs? And I say, no, you probably have to just eat. Maybe it depends how often you want the mTOR signal. You may have to eat more frequently. You may have to eat more, and then you have to give your body a stimulus. So it's both. I was
supposed to say just more. Like, couldn't you just do the 2 meals per day, but just eat a massive thing? Like, I like to just refeed like a maniac if I work out and just want to just eat a whole bunch of meat.
Yeah, you can do that too. So you can, but just so people know how it's all triggered, and then they can leverage it however they want. But I think that we see there are plenty of examples of athletes who are having an incredible performance now on carnivorous diets. I think we're going to see more and more of it, but I think that the athletes that are performing on carnivore diets don't want to tell anybody because it's their secret, like Zach Bitter is not entirely carnivore, but he's mostly carnivore as far as I can tell. And, he's setting records. And I mean, Sean is clearly a pretty exemplary individual. And I know there are athletes in Australia that are performing exceptionally well on carnivore diets.
Well, hopefully I'll be one of those. That's why I started doing the decathlon.
I saw your Instagram, man. I was like, oh, that's holy shit, man. He's like pole vaulting. That's amazing. When I come out to Los Angeles, you got to teach me how to pole vault.
Oh yeah. We could film. We could film at the UCLA track. So yeah, we're filming with Paul for the Food Lies film. We're going to get him in here at the end in the last second here before we finish editing.
I'm going to sneak into the Food Lies. Yes. I'm so lucky. I'm stoked. So yeah, we can talk about this idea. So one of the things that came up, I mentioned in the last episode of our thrilling series that I did an interview with Miki Ben-Dor. I know you've talked to him too, but this paleoanthropology perspective is so interesting. And what he and I talked about, and I'm sure you guys touched on this as well, was the idea that the dietary composition of current living hunter-gatherers is not a good indication of what we were eating as ancestral humans because of the way that the landscape has been changed during our contemporary times. A fantastic example of this are the Hadza. So there are only a few living groups of hunter-gatherers left on the planet, the Hadza, the Ikung. I'm mispronouncing that because it has an actual phonetic sound in it.
Part.
The Ikung. Yes, but the landscape that they're living in is not the same as our ancestors. And Miki Ben-Dor makes a compelling argument that people like Lauren Cordain are misinterpreting the diets of our ancestors in terms of plant-animal composition by looking at living hunter-gatherer groups that are not living in a time that's consistent with what our ancestors were doing. And when we look at the Hadza, they do eat a reasonable amount of plant foods, but they also do not live in a time when they can actually hunt megafauna or hunt the elephants. They're not allowed to hunt the elephants anymore, as far as I understand. And so the elephants end up raging all over the savannah, knocking down these baobab trees. And, the Hadza are using many of the fruits from the baobab and the foods from the baobab because that's what they have available. And so, kind of like I'd hinted at or discussed in the first part of this episode, I really believe humans are facultative carnivores and that we can eat plants during times of starvation. But like I talked about in my YouTube with Miki Ben-Dor, and I've mentioned on my Instagram, if we look at the fossil record, the amount of nitrogen suggests that early humans, Neanderthals, 70, 80,000 years ago, were carnivores. We had more nitrogen in our collagen than the hyenas, and suggesting that we were eating, a fully carnivorous diet or essentially fully carnivorous diet with high level trophic predators in our diet, bigger animals than the hyenas were eating. So I think that we can't use living hunter-gatherers to estimate what amount of plant and animal foods we should be eating. And I think that we've seen that as we've hoped to demonstrate, or as I'm hoping to make the case for in this very incredibly extensive podcast, which I think will be an incredible resource for people. I'm so glad you're giving me this opportunity, my friend. There's plants don't really provide a benefit if we construct the diet well with animal-based foods. But I don't believe that our ancestors were eating 50-50 or a large amount of plants, as was suggested in that podcast.
Well, and it's just the classic story of the drunk guy looking for his keys under the headlights, and the yes. Police officer asks, "Why are you looking? Is that where you lost them?" He's like, "No, but this is where the light is." It's like, yeah, we only have a couple populations to study, and so then we're just basing everything on that. That doesn't make any sense at all.
Yeah. Let's talk a little bit about the blue zones. This has come up a couple of times on my Instagram, and I think it's a really fascinating topic. I did an Instagram post about this, and I'll probably do more, but one of the common things that I hear is this notion. People will say, well, look at the blue zones. They all eat this primarily plant-based diet. And there's a few problems with this premise. I'm not debating that there are parts of the world where there is a higher proportion of centenarians. I think that that's pretty clear. The problem gets to be that there's no really clear evidence that is due to their diet. That is sort of that. I would say that is a made up concept by the people who created the blue zones to sell cookbooks. That's sort of my of like, my brash characterization of that, because there are some really questionable things about the studies that have been done in blue zones that suggest that they're not actually as amazing as we believe they are. And if you look at the research and you talk to people who are thinking about this, generally the understanding or the thinking now is that the blue zones are actually related to clusters of genetics that are favorable. So rather than being about what they eat, these people are thriving in spite of what they eat because their genetics are so good. And, this is something that I think is very clear from genetic studies. We know there are genes associated with longevity. And if you look at these places, if you look at Okinawa or Sardinia or some of these other locales, you'll see clustering, you'll see higher than normal incidence of these longevity genes. There's a couple of studies that I'll point out to people. I've talked about these on my Instagram. One of them is called Genetic Determinants of Exceptional Longevity, Insights from the Okinawa Centenarian Study. And what they find is that there are clusters of these genes that are probably accounting for the longevity in place of, or really that is probably the much stronger hypothesis than any sort of dietary thing.
There's so many different diets in all these different places too. There's no way you can track that.
And people have argued that, in Okinawa, they eat a lot of pork, it's not even a question.
Oh yeah.
It's not a plant.
Regardless of longevity food. I've read about all these things and I've debunked this in a way for each place, right? That there's all of different ways to explain why they live long.
Exactly.
Like genetics or
community, meaningful lives, family, slow pace of life. But to say that it's the diet is is like the worst epidemiology I've ever heard of. It doesn't make any sense.
Yeah.
And it's such a disappointment because Jason Fung and James DiNicolantonio, who I both respect, say this in their book, like, oh, look at the blue zones. They all eat plant-based diets. And I was like, you guys, like, you're completely missing the point. Like, the blue zones are about longevity genes. The blue zones are about having good parents. You blue zones are about having FOXO3 and ApoC3 and, CETP polymorphisms that are beneficial. The blue zones are not about, eating legumes, which I think we would clearly say are not good for humans. I mean, we're talking about beans, like talk about lectins and phyto, like all of these, phytoalexins and digestive enzyme inhibitors. I mean, beans are some of the most toxic things on the planet. You're telling me that a bean is what's causing longevity? Get out of here. You're full of shit. And then there's another one, the genetics of extreme longevity, lessons from the New England centenarian study. It's the same thing, that they find these genetic polymorphisms clustering in these places. And if people have done 23andMe, they can see all of these longevity genes. Like I mentioned, FOXO3 is one. A lot of the genes are involved in insulin signaling. The sirtuin genes are another one. It's insulin signaling, it's insulin resistance, it's inflammation. These are what create longevity. So it's not the foods probably, it's the genetics. And I think the most interesting one, you're going to love this one. So food intake, diet, and sperm characteristics in a blue zone, colon, a Loma Linda study. So this one is just so amazing. So they said, so they looked at Loma Linda, which is one of the blue zones that is in Southern California. And these are, vegetarians, vegans in that area. And they said the study showed that the vegetables-based food intake decreased sperm quality. In particular, a reduction in sperm quality in male factor patients would be clinically significant and require review. Furthermore, inadequate sperm hyperactivation in vegans suggested compromised membrane calcium selective channels. Like, if that's a blue zone, I lost my mind when I saw this study. Like, what? Yeah. This is a blue zone. This is the biggest load of shit I've ever heard. Like, if people are living longer, it's because of their genetics, and their sperm look like horrible. Like, they have the worst. Like, and of course, these findings are probably based on mitochondrial health, and they have lower sperm numbers. The sperm are not as vigorous. They're not as they're not as good. They're not as good at swimming. So that's clearly indicating or strongly suggesting a nutrient deficiency in these people. Like, and this is considered a blue zone. It drives me crazy. Like, what are you talking about? If you think that is, you want to eat the diet that those people are eating, then be my guest, because, like that's a very confusing finding to me to suggest that that's an actual blue zone. I think that just disqualifies Loma Linda as a blue zone. I mean, just because the people live longer doesn't mean they're healthier. My strong opinion that the blue zones are a misunderstood concept. They exist, but they are about genetics. Like, study genetics if you want to study a blue zone. Don't study the diet they eat.
Well, my favorite study concerning Loma Linda people is the Mormons, comparing them to the Mormons. Yes, okay, maybe the Loma Linda people live a long time, but the Mormons have all the same good things going on. They have a good sense of family. They don't smoke. They exercise. They don't drink a lot of alcohol or at all. But they have no restriction on meat. And guess what? They live longer than the Loma Linda people.
But they're not considered a blue zone because they're not in one space.
Yes. So, but how amazing is that? It's a pretty comparable thing with no restriction on meat, and they live longer.
Yeah, I think that the blue zones get cited a lot. And that's what I tell people, like, hey, it's about genetics, look at the Okinawa studies, look at this New England centenarian study, and then look at the sperm characteristics of the people at Loma Linda. And you tell me, I'll leave it up to you, do as you will. I think fertility is a very great indicator of overall nutritional status and a good predictor for, quality of life. But maybe people feel differently. Yeah. I don't know. I thought that was really interesting. So
here's another one, longevity, that we miss is the methionine part, and then the glycine to methionine ratio.
Yeah, man, this is super controversial online right now. I think that a lot of people misunderstand this, and I'll just try and lay it out for people. If we look at the rodent studies, it's quite interesting. So I think that one of the problems, I think this ties back to a lot of the people that have misinterpreted protein diets and rodents being tied to lower longevity. So there were studies done in rats in the 1950s and 1960s that showed when you gave rats a high protein diet, the rats lived a shorter amount of time. But what they figured out was that they were giving the rats a high methionine diet, right? So in rats, it was a 2% methionine diet that caused a reduction in lifespan. And so they realized, oh, it wasn't the protein, it was the fact that the methionine is toxic. And then they did another series of studies, and they said, oh, if we limit the protein in rats, they live longer. Well, what they were really doing is limiting the methionine in rats, right? And if they limited the methionine, they lived longer. And then they did another set of studies and finally figured out that they could get the same benefits in terms of life span extension when they supplemented with glycine. And it brought up this idea that in mice, which have essentially the same biochemistry around folate and the biochemistry involving methionine and methyl groups, which is what we're dealing with here, when they gave the mice more glycine to balance the methionine in their diet, they had extension of life. So the study is glycine supplementation extends lifespan of male and female mice. Well, this is from September 2018. And, I posted this on my Instagram and I said, mice are not humans, but it illustrates the biochemistry. And I would still not want to take the position that mice are humans, but I think it does illustrate the biochemistry. And so the argument that I have here is that within a carnivorous diet, meat is approximately 2% methionine and 7% glycine. And so the question becomes, at what point of eating only meat do we get to a high methionine diet, right? So is eating 2% methionine and 7% glycine, is that a high methionine diet? I don't know. And so if you look at the collagen is about 0.9% methionine and about 23% glycine. So collagen has a very different ratio of those amino acids, which you would expect. And so in my opinion, a 2% methionine to 7% glycine is bordering on too much methionine. And again, this is a little bit of conjecture and I can't tell for sure without measuring an individual's biochemistry. And that's why we do laboratory testing in functional medicine, as we look at these things. But I worry that just eating meat, we are going to simulate the diet of these methionine-rich mice experiments. And
muscle meat, you mean? Just the muscle meat?
Yeah, it's just muscle meat. Yes, just muscle meat, right? Not connective tissue, not bone broth, none of these glycine-rich foods. And so the methionine-glycine ratio is just about being healthy. It's just about saying, hey guys, what is the harm in supplementing with glycine in a variety of forms to make sure that you are getting glycine in your diet to balance this methionine? And if we tie it back to ancestral norms, we will talk about this idea that if we were eating the whole animal, we would have been getting, muscle meat and connective tissue. We're not going to waste the connective tissue. We know that we would have eaten bones. I want to talk about calcium as well, but we would have eaten bones. We would have eaten collagenous tissue. And that is where we would have gotten more glycine in the skin and the hide. We know that the hunter-gatherers will eat the skin sometimes, or they'll eat the soft parts of the bones. They'll eat the connective tissue. And so that's important. That's
the marrow.
Yeah, the marrow. Those are the connective tissues. I mean, the marrow is mostly fat, but we will get high glycine foods in our diet if we're eating the whole animal. And so I fear that people in carnivore world will just eat the muscle meat and they won't get enough glycine, which could cause a real problem. So this is the issue that I think we need to think about, this methionine glycine balance. And we know that this is a real issue. If there are other studies, Chris Masterjohn has done some great stuff here. He did a whole podcast on methionine and glycine. There's another study that talks about the fact that in humans, who are eating a mixed diet, we probably don't make enough glycine. So the title of the paper is "A Weak Link in Metabolism. The Metabolic Capacity for Glycine Biosynthesis Does Not Satisfy the Need for Collagen Synthesis." So the idea in this study, this is in humans, that most humans, when they did the metabolic studies, fell about 10 grams per day short of their glycine requirements. Now, a couple of things about this. Glycine is conditionally essential, which means that we can make glycine in our body, but we probably can't make enough of it, at least in the setting of a mixed diet. The question is whether we can make enough of it on a carnivore diet. And I would argue that just a meat-only carnivore diet could be a high methionine diet and might also result in a glycine deficit. So why not include collagen in your diet, or include glycine supplement as an amino acid, or include bone broth or connective tissue, right? It makes sense. And I don't see a lot of downside to this. So I'll just clarify a little more. Glycine is an amino acid. It's a very simple amino acid, but it's used in the synthesis of multiple proteins in the body, but two of them are critical, and we've talked about them a lot. One of them is collagen. which is 3 amino acids, which is glycine, proline, and hydroxyproline. And the other one is glutathione, which is glycine, cysteine, and glutamine. So if you don't make enough glycine, as the title of this paper suggests, you're not going to make enough collagen, and you're also not going to make enough glutathione, which is probably where the life extension benefits come from. I mean, everything comes back to glutathione. You know, how many times have we talked about glutathione in this long form, extremely in-depth podcast, you know? And we need enough glycine to make glutathione. So when anyone argues with me about methionine glycine, I just think like, well, why don't we just test your glutathione? Like I can show people these things. Like it's an easy test. You know, if people are curious about their methionine glycine ratio, they should get an organic acids test and look at pyroglutamate. They should look at serum levels of glycine, and they should check their glutathione level, both oxidized and reduced. And if you look at those three things, you'll get a very good sense of your glycine to methionine ratio. You can even check a serum methionine level and get a sense of that. So these are all testable. It's not even research anymore. You know, like we can do this within the functional medicine world very easily. And I've done it on my patients, and I see it in clients. You know, I see very commonly that people have elevated pyroglutamate, which is an indicator that glutathione is not being made properly, that it's being wasted. And it's usually an indicator that glutathione is not being made properly because there's a glycine deficiency. And they have low serum glycine and they have low glutathione. And it's like, look, you need more glycine. It's really simple. And so people want to argue with me about this online. I say, well, just go get a test. You know, I can tell you, you know, prove it to me. So anyway, that's the methionine glycine thing. I think that a lot of people probably don't need to get any testing. They just need to supplement with some sort of collagenous tissue or just the amino acid glycine and sort of mimic that ancestral physiology of eating the whole animal. So does that make sense?
Absolutely, which kind of leads into bone meal, which you eat as well.
Yeah. So as we kind of talked about, I'm so interested in this nose to tail way of eating. And as I've talked about before, I'm going to eat muscle meat. I'm going to eat a decent amount of fat with that to create a certain fat to protein macro, usually around 35% of my calories from protein, 65 or 70 from fat. And then I'm going to eat some connective tissue like we just talked about with methionine and glycine. I'm going to eat organ meats for complementary nutrients, the B vitamins, the copper. And I'm also going to eat some omega-3 source, the salmon roe, the phospholipid DHA that I've talked about in the past. And one of the other things that I eat is bone meal. So I eat bones from animals, and I either go to the butcher and have them grind up bones, or I buy bone meal online. And I try to be careful about selecting a bone meal that's been analyzed for levels of heavy metals and meets Prop 65 standards. So I try to get a good bone meal from a grass-fed organic animal that I know is low in heavy metals. But the reason I do that is because I really believe that humans need calcium, and we see this in human physiology. We need calcium. It's not even a question. We need calcium. And a lot of people on carnivore diets are not getting any calcium source. And as we've mentioned earlier in the podcast, I don't think dairy is a good thing for people to have in their carnivore diet, at least in the beginning. A lot of people are coming to carnivore very sick with autoimmune conditions. And I just feel like dairy is going to trigger a lot of autoimmunity. And people with dairy seem to have issues with satiety and weight gain, probably having to do with casomorphin.
And it's all pasteurized and there's a million things. But I mean, some people can do it right. I mean, I would say if you're milking your own cow, and even if it's an A2 cow and you're doing your own fermented kefir or like cheeses and you can handle it, then go for it. But for the most part, you know, maybe people have problems with it.
Yeah. And I never completely rule it out for people. You know, I've seen people who seem to tolerate it just fine. But if people have autoimmune issues, I always say like, yeah, don't do dairy in the beginning. Don't even do butter. Let's just make a really simple experiment here. And I think that that's what most people should try. And in a lot of the clients I've worked with, they feel better off dairy and they're able to lose weight off dairy and they don't overeat. It's just a better situation. But, you know, if you're not eating dairy, where's your calcium source? And I think that our ancestral calcium source would have been bones. And we would have either ground them up or gotten little bone flakes when we were eating bone marrow, or eaten the soft part of bones, or, you know, eaten small bones from animals. I know that Inuits grind up the fish bones and the fish, and, you know, people who eat sardines know they're eating fish bones. So we need calcium. We need bones in our diet to really be eating nose to tail. And people might think of this as like a minute detail, but I would argue it's very important for a variety of reasons. And this will tie back into some of the things that were also brought up in that podcast with Dr. Tro and Dr. James Nicolantonio. One of the concerns that Dr. Nicolantonio had on that podcast was that meat that was not fresh would have the porphyrin ring break down, and that the free iron in the meat would be absorbed and be a problem in the human body as an oxidant. I'm not convinced that the porphyrin will break down in the meat. I'd like to see some science about that. But, one of the things that we know is that calcium will work to sort of balance the iron in the bloodstream. And if we look at heme iron, Heme iron, has also been suggested as one of the carcinogenic components of meat. But the studies of heme iron that showed that it was carcinogenic were done in calcium-restricted mice. That's the only situation in which we've been able to find a detriment to this iron from animal foods, this heme iron. So I don't think heme iron is a problem as long as we're getting enough calcium. And I thought, oh, that's really interesting. James DiNicolantonio was arguing for plant molecules and plant polyphenols to chelate the iron. I thought that doesn't make any sense. I wouldn't do it that way. I would just have enough calcium in your diet, like a true, hunter-gatherer or a true hunter eating nose to tail. Have enough calcium in your diet, and you get that from bone meal. So bone meal or eggshells, those are the two sources of calcium that I think are the most accessible for people. But I think that a nose to tail carnivore diet does need to include calcium for that reason, among other reasons. We need calcium for other things in our body. But, if we're worried at all about iron or heme iron or, iron in our bloodstream oxidizing anything, then we just want to make sure we have enough calcium. And again, I'd like to see the literature that actually substantiates the fact that the porphyrin ring breaks down. I'm not sure I believe that. And I think that the meat would have to be pretty darn rotten for that to happen. But I'm willing to consider it. I just think that there's ways to mitigate it, and it actually points toward the importance of a calcium source in our diet. And then there's one other thing that I think that will be really interesting to talk about that I've never talked about on any podcast. So this is super bonus. If people have made it this far, I think this is really cool. And this is the issue of bicarbonate. And I do have to give a hat tip to James DiNicolantonio for making me think about this. Even though I'm sort of disagreeing with him about a number of things, I think we're going to find some commonality here and find this to be quite interesting. So one of the things that he pointed out was that plants are a source of bicarbonate. And this is actually something that I've observed, and this will be interesting for people to hear about, because there is a lot of talk on the internet about acid and alkaline diets and how you can eat acidic foods and they're going to create an acid state in your body. Well, that's hogwash. There's no such thing as, you can't alkalinize your body. That's not true. Your pH in your blood stays the same. It's very tightly regulated, but the pH of your urine will change based on the foods that you're eating. And there are some things that are involved in that. And there are some contributing factors to the pH of your urine that may be relevant here. So what I have seen on people on a carnivore diet is that they tend to develop a very acidic urine pH. And I think that this could be associated with some loss of minerals, specifically magnesium and potassium in the urine. And one of the things that people sometimes experience on carnivore diets or ketogenic diets is electrolyte deficiency or benefit from electrolytes. And I think that, supplementing with adequate sodium is going to ensure adequate magnesium and potassium status. And sometimes people supplement with magnesium and potassium. And that's always kind of bothered me. I'm like thinking, if this is the diet that our ancestors were eating, were they cramping up all the time? Like, how did they supplement with magnesium and potassium? What is going on here? There's no such thing as you can't get a magnesium supplement. It never made sense to me. And so when James was talking about this, it kind of all clicked. And I thought, oh, that's really interesting. So what he was saying was that there's bicarbonate in plants, and that the bicarbonate in plants might balance some of these acid forming compounds in the urine. And so what the body does is, it's in order to keep the pH of the body normal, it's going to create a little bit more acidic urine. And when it creates an acidic urine, there may be some things that are needed to buffer it, or, this is where the magnesium and the potassium and some of the other electrolytes get used up potentially. Right. So we could check this in urine. We could look for urinary magnesium, urinary potassium, and see if the pH of the urine is correlated. But I will say that I have seen a low urinary pH, which means an acidic urinary pH in carnivore patients. And I think that what's going on here is the bicarbonate thing. And it's not that we need bicarbonate from plants. I believe we were getting bicarbonate from water. And if we look at this, and James mentions this in the podcast, if you look at Gerolstein or any of these mineral waters, there is a higher amount of bicarbonate in that water relative to tap water. And I thought this is such an interesting concept. I'd never thought of this before. So it's really pretty wild. That if you look at spring water, if you look at fresh water in lakes, if you look at mineral water, quote unquote, it has more bicarbonate than tap water. And they've actually done studies on this. I never thought about this. You're eating nose to tail carnivore. You actually have to think about the water you're drinking. You have to think about the bicarbonate content of the water, because nose to tail carnivore also includes the water. And everybody says, what do you drink? I say, well, tongue in cheek, I'll say I drink Topo Chico. And I love Topo Chico. I wonder if this is one of the reasons that I like it so much, because, Gerald Steiner, I think Gerald Steiner has been documented to have 600 milligrams of bicarbonate per liter. I wouldn't be surprised if Topo Chico has a lot of bicarbonate per liter as well. And I think that what we're getting in these mineral waters is bicarbonate. And this is not an argument in my mind that we need to be eating plants. It's an argument that we need to be drinking spring water or getting some bicarbonate source, which you can just get by using baking soda if we can't obtain spring water, or people don't want to drink mineral water all day, every day. I mean, I think you could do worse than drinking Gerald Steiner every day. I wouldn't mind that. And I probably could live on Topo Chico. I'd be burping all day. Maybe if Topo Chico would make a flat version, I could just drink Topo Chico all day and I'd be fine. I'd probably get a decent amount of bicarbonate. But if we're drinking tap water, there's much less bicarbonate. And so, I pulled up this study. It's called The Consumption of Bicarbonate-Rich Mineral Water Improves Glycemic Control. I thought it was so interesting. Basically, what they did in the study was they looked at glycemic control through a variety of measures, and they compared spring water or mineral water to tap water. And what they saw was that the bicarbonate-rich mineral water had a better control, or resulted in a better control of the glycemic parameters in these type 2 diabetics, or in type 2 diabetic humans. And I thought it was so interesting. Both, they documented that the mineral water was more bicarbonate rich than tap water, and that it increased glycemic control. So this is an interesting idea that, like, wait a minute. I mean, James argued that's why we should be eating plants, is for the bicarbonate. And I would say, no. I mean, yes, maybe that's one benefit. But I would argue we can just get mineral water, or we should just be drinking fresh water. And I've often thought this is the one piece of the whole equation that we really can't undo. We can't live outside all the time. We can't drink fresh water. If you go backpacking, you can drink water out of a stream, and I can guarantee you that water is higher in bicarbonate than tap water. Or you can get mineral water from a spring, or you can drink, water from an artesian well, which might be higher in bicarbonate. But it's such an interesting idea that we need a little bit of bicarbonate in our diet. And so the way to address this, I would suggest to people as a take home here, is add a little bit of baking soda to your water, and not a ton, because baking soda is quite concentrated. So when I researched this, what I realized was that in half a teaspoon of baking soda, so a small amount, like 2 grams of baking soda, has about 1,600 milligrams of bicarbonate. And that's probably adequate for anyone in a given day. I'm thinking, how many liters of Gerald Steiner could you drink in a day? 2 or 3. So something like maybe 1,200, 1,800, 2,000 milligrams of bicarbonate, I think, is all people are going to need in a day to balance this in their bodies. And so one of the things that I'm going to start doing and recommending to my clients is to check a urinary pH. People can get these urinary pH strips. And if they want to do this experiment, I think it would really, really interesting to document in the carnivore community. Don't do any bicarbonate, and then check your urinary pH. And I wonder how many people in the carnivore diet will have a very low acidic urine pH. Incidentally, what is considered normal as a urine pH is anything around 6. 6 is the average value for urine pH. Anything under 5 is acidic. I've definitely seen urine pH values around 4 or less in carnivores. And so I thought, that's really interesting. So anyway, I'm going to start doing this and encourage people in the community to try it out. But I think that we know that having some bicarbonate, whether it's from mineral water or sodium bicarbonate, which is baking soda, or the consumption of plants, will raise urine pH, that is, make it less acidic. And I wonder if this could improve mineral maintenance, because one of the things that people realize is that they always have to just be taking magnesium all the time. I don't think we should have to do that. And my hypothesis
could be it. Yeah.
is that by normalizing urine pH, by drinking spring water, by drinking nose-to-tail water could result in a little better retention of these minerals.
Wow.
So I wanted to talk about that. That was really interesting.
Yeah, that's great. Nose to tail, everything. This is funny because I've been wanting to launch this for a long time, and I think this is when I finally bring it up. I've been working forever to source the best meat I can and provide nose to tail products. Like, I never wanted to advertise anyone else's products. I wanted to make my own thing. And I found this amazing ranch way up in Northern California that does everything grass finished, raised everything, no hormones, no antibiotics. And they're making me special meats, and I'm doing nose to tail foods. I have nosetotale.org, and I'm putting out products that you can order. And one of the products, speaking of bone meal, is a ground beef with ground liver, heart, and bone meal.
I love it.
So they're making that for me. Yeah.
I'm going to be one of your first customers.
Yeah. I'm so excited about it. I seriously couldn't even sleep last night. I was thinking of the different products and different sausages with, squeeze in some liver in there, squeeze some heart, squeeze some tendon. They have just the most amazing stuff. They have bison. They have all kinds of different cool things that they're offering me and helping. We're formulating them right now and getting the ordering system worked out. Yeah, you can make your own box. It's kind of like Butcher Box, but better. The meat is so delicious too. This is like turning into an ad, but nosetotale.org, and
sign me up, dude. I'm there. I want to be customer number one.
I can't wait. Well, and you know what we're doing? We're putting in. People keep asking you, where do you get your salmon roe? And people ask me, where do you get your cod liver? Where do you get your? Basically, we're going to provide all of those in the box, so you can have those as add-ons. And so just imagine you can make your own box, get it shipped to you the next day, and it can have all these weird things in it that are hard to find. That are the nutrient density.
That are nutrient dense. That's amazing.
Yeah,
that's super exciting. Yeah. That's super exciting.
So excited.
Well, maybe that's a good segue to like a little bit of an ethical conversation before we wrap up.
Yeah, exactly. That's why I found these people, well, for one, for the health benefits, but they really care about, sustainable regenerative agriculture. And yeah, that is a huge topic I wanted to talk about, because people are like, okay, so now what? So we can't feed the world. People always say, well, we can't feed the world if everyone eats animals. And I think we can. And I've talked to a lot of people. There's all these Alan Savory people that are, talking about using animals and regrowing the land.
Yes.
And we have millions of acres growing corn, wheat, and soy.
Right.
What if we just grew regeneratively grown plants and animals together, right? It's no-till farming. Instead of growing these annual crops that you have to dig up every year, you grow perennial plants and animals together, and the soil gets built every year, and the land gets better, the soil gets better. And I think we 100% can. We have so much earth, right? I mean, there's so much arable land on this earth that we could, if there was a demand for it. It's not going to happen overnight, obviously, but if the world slowly shifted to an animal-based diet, there's more than enough land to do it.
I completely agree. I think we should just break it down for people a little bit. Let's just back up a little bit and say that if we look at carbon emissions and greenhouse gas emissions, you have to be very careful the way the study is written, because people are, really massaging this data in various ways. But, the majority of greenhouse gases are from automobiles and industry. Make no mistake, no one listening to this should be
energy.
Yeah, it's energy generation. It's automobiles and industry. So until we stop using computers and cell phones and automobiles, which none of us wants to stop doing because it allows people to hear this podcast and share this message, like that is where the majority of greenhouse gases are. So anyone that is saying that cows are contributing to greenhouse gases is like, well, it's a very small percentage of the equation. And if you actually look at the amount of greenhouse gas that comes from agriculture, it's about 12 to 13%. And about half of that is plant agriculture, and the other half is animal agriculture. Mm-hmm. So to say that cows are contributing to the greenhouse gases is just wrong. And you also have to admit that there are greenhouse gases made in the production of plant foods, whether it's the tilling of the soil or the harvesting of the soil, and, like the movement of the plants around the planet. And nobody really talks about the carbon footprint of moving plants around the planet. And so the greenhouse gas thing is just really, in my opinion, a straw man. It's like, that doesn't make any sense. And the work of Alan Savory, I think, is really interesting in regenerative agriculture. This idea that by putting ruminants on the ground and allowing them to graze properly over areas of ground can actually increase the greenhouse gas carrying capacity of a plot of soil. So So his theories are quite compelling that we could increase the carbon carrying capacity of the soil by putting ruminants on the land. So it's not that cow farts are the problem. It's that, that we're not letting the cows graze the way they should, and that we're putting them in pens, and then we're not moving them around properly. And that is a main issue, and that the soil is not healthy enough. And so people need to understand that those things are often misconstrued. And then if we're talking about the killing of animals, that's an ethical thing that probably isn't worth really digging into now. People have talked about these sort of collateral kills, all the animals that get killed in the harvesting of agriculture, that there's there's millions of animals, like more animals get killed when you're harvesting plants than the cows that are killed. I mean,
that's what I said. I put out a post too that people liked, is I can eat a cow for a year theoretically and only kill one animal.
I've talked about this before. I hunted for a season, and I think at some level we all have to admit that in order for something to live, something else must die. And that's the way of life. And for me, that creates an imperative to live a good life. And it's like, I think that one of the things that's a disservice to humans is that we're separated from the process of harvesting our animals. And then when you go to the grocery store, you just see a steak. You don't see the animal that it came from. I almost wish there were pictures of the cows that the steak came from, because I think people would probably buy less meat, which may not be a good thing for human health. But I think that those of us that did buy meat would say, like, that's an animal. Like, I'm eating that animal. The way that I feel about this, I don't know if everybody else feels the same way, but the way that I feel is like, that's a spiritual imperative for me to be a good person. Like, I think that I'm going to be a kinder.
Thank that animal.
Yeah, thank that animal, and then live in a way that's thankful for a life. I mean, this is starting to sound kind of woo-woo, but like, I'm alive. I didn't do anything to really merit being alive. I just found myself alive. And, I'm thankful to the animals that are providing food for me. And, that's just the equation, and that to me really comes with an interesting imperative around, I want to live well. I want to be kind. I want to develop into my best self, however I can do that. So I think that it's okay to be connected to the animals we eat, and to understand that that's a spiritual process. And I don't always understand why people say, like, well, I'm killing less animals. It's like, look, you're a life on this planet, man. If you believe that you are not impacting other animals, then you are deluding yourself. This is not the case. Like, we are all on this earth. We all have a footprint, whether it's a carbon footprint or the fact that we are, consuming animals or killing plants or whatever. Like, we're all going to need to kill things in order to live. And anytime that we are using things, I think we should be aware of the fact that we should be grateful to that life, that it's nourishing us. And, if you look at like spiritual Native American traditions, they talk about this. They're, perhaps I'm romanticizing this, but my limited knowledge of this suggests that, when they're using a plant, they're thanking the plant for that thing. And, that's the same idea. Like, you are using a plant. Did you thank the plant? Like, we all have to thank the things that are feeding us, whether they're plants or animals or whatever. And so, I think there's a spiritual component there that's important to consider. And I don't see, eating animals to be any ethically different than eating plants. I just see a spiritual imperative in both of those processes.
Absolutely.
And as far as the ethics go, I think that has to do with the greenhouse gases and the sustainability and stuff. And we've talked on, I just wanted to touch on that a little bit, And the other thing that, Sean Baker pointed out to me is that, a lot of people who are eating plant-based diets, in order to get enough leucine to really trigger mTOR and an anabolic process, you have to eat so much pea protein that it takes like so many more resources to produce the amount of pea protein to trigger an anabolic process. So we clearly know, and your post on Instagram today highlighted this, we clearly know that animal food is just so much more efficient at nutrition and nutrient density. If we were to do a study or an analysis that compared, for any given amount of nutrition, if you were to try and equate plants and animals, I think that it's very clear that you're going to use so many more resources to get to any amount of nutrients eating plants, because there's so much less nutrient dense and so much less bioavailable. To say that we're using more resources with animals is absurd. Like,
it's absurd. They say the opposite. They're like, all the cow needs is sunlight and eating grass.
And we can't, and humans can't eat grass, So we would die.
You're not taking away our food.
It's food that humans can't eat. And, I was talking to one of my friends from Nourish, Balance, Thrive today. And, he was, saying that he grew up in the northern part of Europe, and up there in the winter they have, deer that eat moss, and humans can't eat moss, and so the deer are eating the moss and turning the moss into steaks. It's like same thing with a cow. That's turning grass into steaks. Like,
it's a miracle.
It's a miracle.
Yeah.
It's a steak maker. It's magic steak maker. And that's like, humans can't live on grass. So it would kill us. It's too much silica. So why are we, it's not a resource, not taking a resource away from humans.
Yeah. It's crazy. We shouldn't even talk about it anymore because it's just too maddening to think about people who don't understand this stuff. So you brought up some muscle building. I wanted to ask like a few, we'll do like more rapid fire. It's a few things at the very end here because you're a muscular dude, What are your workouts like? I just like to do like brief, intense workouts and you just have some protein and it's pretty much as simple as that. I mean, do you even need supplements?
I don't take any supplements right now. And I've made it sort of one of my curiosities and personal journeys to see how I look and feel and how my blood work looks with no supplements. So no, I don't do any supplements. And I mean, I clearly have an anabolic stimulus. I mean, I haven't lost any muscle on a carnivore diet. Anyone that's worried about losing muscle on a carnivore diet can look at Sean Baker. And I mean, my body type is not like Sean Baker, but I'm a muscular guy. It depends who you put me next to. Yeah, I do moderately intense workouts most days of the week. And for me, they're, hitting the punching bag and doing some Muay Thai and some movement work, like gymnastics type work. And then, when I can get out, I'll go surf. I think when I get down to San Diego, I'll be doing more surfing. Surfing is kind of that like long, moderate, activity rather than like brief, intense. I guess surfing could be bouts of intensity.
Balance it out.
Yeah. I mean, surfing is kind of like bouts of intensity. You're paddling for a wave and then you're paddling back, to the line up from a wave. And then you're just kind of hanging out for a while. But yeah, surfing's pretty intense for sure. But, hitting the bag is a little more intense. And so that's the kind of stuff I do. I don't do any weightlifting. I just
really?
No, I just do body weight.
I didn't know
stuff.
that.
Yeah. I don't do any.
Oh, okay. Yeah. I like body weight stuff too. I got a weight vest and I'm almost up to the max at 40 pounds on the weight vest.
Yeah. I recently got an X3, which is kind of cool. It's like this banded system that I can work out with. I kind of dig that too. It's like you can simulate some pretty incredible weights with just bands in your home. It's a really efficient thing. It's pretty cool.
All right. Well, so maybe I'll try to balance this out. What are you least sure about? What are you said all this stuff. It's so amazing, but are you kind of questioning some of this?
Oh, everything, man, everything. I mean, there's so much to learn. Somebody sent me some stuff about ApoE recently. And what about, I think there's a lot of questions about saturated fat with ApoE4 polymorphisms that I'm looking into. And I think that the paradigm around ApoE4 is not well understood. And I think that ApoE in connection with Alzheimer's and dementia is a very fascinating question. And I'm definitely, looking into that more now and really digging into this thing. And we didn't have time to talk about it today, but I think on future podcasts, people will hear me talk about, all this data suggesting saturated fat and endotoxin or lipid rafts. That doesn't seem to hold up when I look at it, but I'm really digging into that kind of stuff. All this data, like where's all this misconception that saturated fat is bad for humans coming from? And, I think that there are some studies that make it look bad and you really have to look into it with a fine tooth comb. And the ApoE4 stuff is interesting. And some of the endotoxin stuff is interesting. I mean, briefly on the endotoxin, in some studies, people would say, oh, if you feed people more saturated fat, they have higher levels of endotoxin. And, this doesn't seem to hold up clinically because all the carnivores I've seen have the lowest CRPs, on the planet. And it doesn't seem like they're getting a lot of inflammation from eating saturated fat and meat. So there's some discordance here. Incidentally, a lot of the saturated fat trials with endotoxin are done in people who are metabolically unhealthy. They're people with PCOS and metabolic syndrome at baseline. So I think that kind of confounds it. And they're using a lot of dairy fat, which kind of goes back to the dairy question, good for some people, not good for others, but who knows? So yeah, I have a lot of questions about saturated fat. A lot of questions about ApoE. I don't really have concerns about saturated fat, but I want to help flesh that out for people so they can really understand it in more detail. And, I think the electrolyte stuff was interesting. I kind of thought this idea about bicarbonate was quite interesting. So the electrolyte stuff is interesting. And I'm interested in understanding that because I really don't think that, maybe I'm wrong, but I just don't think that we should have to worry about electrolytes on a ketogenic diet or a carnivore diet. And then there are all these people saying, things about hormones and ketosis that I'd like to flesh out a little more. People are worried about, I've heard like long-term ketosis can be bad, and I don't agree with that. I haven't seen any evidence to really support that, unless you're calorie restricting. So yeah, there's a lot of these questions around that I think are still not fully understood, and I hopefully will be able to contribute to clearing those up.
Yeah. And then you brought up CRP, and we forgot to talk about that, or like CAC scores. Just really quick, that people, the vegans will say, oh, meat's inflammatory, you're going to die, all these things. These carnivores, you're doing blood work on people, and they have very low C-reactive protein. The CAC, we've talked about on this podcast before, is the calcium, the calcification of your arteries. Like all this stuff is just flawless doing the carnivore and actually turning around. And people who are metabolically damaged, and had these calcifications actually reversing, which people thought CIMT couldn't even reverse. I was just talking to Dave Feldman. He's like, yeah, mine was going down. It's like people didn't even know that was possible.
Yeah, I love Dave's stuff. It's totally true. Like the idea that meat is inflammatory. I did a YouTube video about that. I was like, that is the biggest load of hogwash I've ever heard. And there have been interventional studies. I'll have to find them for you, that show that when you add meat to diets, inflammatory markers don't go up. But I don't know where this idea that meat is inflammatory comes from.
Well, it's because you're eating a hot dog bun with the meat.
Yeah, maybe.
Soda.
Right. There must just be epidemiology. Like there's no.
It is. That's what it has to be.
Yeah. To say meat is inflammatory from an epidemiology study is like, well,
a lot of people think like the whole carb plus fat, like that is a bad combination.
That is a bad combination.
Right? In the context, maybe it's not the meat, it's not the carb, it's the combination.
Yeah. Ted Naiman has talked about that. This combination of carbohydrate and fat doesn't occur anywhere in nature except breast milk. And it's an incredibly addictive combination. I mean, carbohydrate plus fat is basically what ice cream is. And it's like, whoa. Mm-hmm. I mean, to me, ice cream is basically like, that's like a mimic of breast milk. And we just go back to the ancestral, breast and just eat the shit out of it because we feel like
designed to make babies fat.
It's
designed to make babies fat.
Yeah. So that doesn't occur in nature. And, all of the most addictive foods have mimicked that combination. I mean, look at a Snickers bar, it's carbohydrate and fat, and a Krispy Kreme donut, it's carbohydrate and fat. There's no protein in those things.
Every single study that we've done, these big epidemiological studies and all this stuff, are flawed because of this. They've never teased out like a carnivore population or like a really, nutrient dense, like ketogenic diet that's really, like what you and I would do. So
they have not. They have not. I think we said this in the first podcast. I feel like every time someone cites an epidemiology study online, on the news, on a podcast, there should be a disclaimer. It should be illegal to not tell people it's epidemiology. Like I have to tell you it's epidemiology. It should be like a legal clause.
But even if it's not epidemiology, even if they do like a randomized controlled trial, but if they're giving people the combination of the fat and the carbs together, they can still throw it off, even if it is well controlled.
Totally throws it off. Yeah. Absolutely.
So would you give your kids a carnivore diet?
You didn't tell me you were going to ask me this.
I did not tell you this. I'm trying to throw in some hard ones at the end.
I think it would depend on my partner. It would depend on my partner and what the environment was. I've talked a little bit in the past about, there are probably less toxic plant foods, but honestly, at this point, I think there are examples of kids who are doing just fine on mostly carnivorous diets. Would I want my kid to not ever eat birthday cake or have this completely different life than other kids? No. But I probably would try and educate them along the way. So I think that, kids are fairly flexible, and I would probably have to walk that line pretty carefully. I would really carefully construct their diet and make sure it was very nutrient dense. Mm-hmm. I definitely would give my kids salmon roe and liver, that's for sure. Yeah. And I would definitely give my kids, a lot of healthy fat and muscle meat and, and connective tissue. I would definitely give my kids a nose to tail carnivore diet, probably with some plants every once in a while, just to create variety or because they would be curious. And, I think there are some plant foods that are less harmful than others. And I think that, evolutionarily humans probably ate some plants during times of starvation. And I don't think it would be bad for my kids in the long run. And I mean, having not had kids, everyone who has kids and listening to this is going to say, like, you don't know what you're talking about. You don't have kids. You don't know how hard it is. And I will admit, you're probably right. I don't know how hard it is, but I'm just speaking from a conjecture standpoint. Like, I wouldn't want to deprive my kids or create this like uniquely wild experience for them that like, oh, my family just eats meat. Why do you eat vegetables? That's weird. But, I would try and walk the line and explain to them, like the animal foods are the most rich foods. And, I would give them the choice, as they develop the ability to make choice, like, what do you want to eat? Like you can have salmon and you can have salmon roe and you can have steak, or if you want to have, some squash, you can have that. And I let them choose to some extent, but yeah. So that's an interesting question. I've thought about that sometimes, and it's often been like, whoa, what would I do for my kids?
Well, have you heard of a woman, Tara Couture? I did a podcast with her. She's at Slowdown Farmstead on Instagram. Amazing. You have to listen to this podcast with her. She's raised her kids 20, some of them are 28 now. They've only eaten animals that she's raised and butchered, and she's done it for 28 years herself. She's 50. She looks amazing. She looks like she's 30.
Oh my God.
This is the most amazing woman you've ever met. I'm gonna go fly up and visit with her and film with her for the movie. She's been on the Weston A. Price podcast, and I just can't say enough about her. She raised her kids like this, and they never been to the doctor. They have no cavities, perfect teeth, strong. Her youngest daughter plays on the boys' hockey team. She squats like 225 pounds. Her claim to fame, the daughter says, I'm going to, on my tombstone, it's going to be the kid that never went to McDonald's. So she's chosen to never go to a fast food restaurant. And she said, sometimes they'll go to a friend's house once in a while. They'll eat some of those normal foods and they'll feel sick and regret it and hate it and not want to do it again. Yeah,
but I think that, in my non-experienced position, I would say that kids probably need to have the freedom to do that. So,
Yeah, that's what she did. She let them do it. Last thing, people always want to know, what are the safest plant foods? Avocado,
olive, squash. I when I get asked this, I think at this point, and this is going to be something that's evolved, so maybe in the future I'll change my mind, but from my perspective, it would be the non-sweet fruits. We kind of talked about fruits on the first podcast and how I'm not super excited about them, but I think it would be the non-sweet fruits like avocado, olives, and then you get into a carbohydrate-rich fruit, technically like a squash, but I just feel like if I were going to eat a carbohydrate food, it would be a squash. People sometimes say, oh, what about sweet potato? And I'm like, yeah, I think it's one of the more benign tubers, but sweet potatoes have a decent amount of oxalates. Maybe cucumber without the seeds or the skin would probably be that. Or, like the non-sweet fruits might be in that list too. The berries, although a lot of the berries are quite high in oxalate or decently high in oxalate. So something like that would probably be the reasonable foods, and I think, like I said in the beginning, I just think people have to get an accurate sense of where they are, where they want to be, what their goals are, and kind of titrate for that, solve for quality of life. And if you're super sick or you're interested in optimal and you want to try the full thing, like I've said before, I don't think humans need or need plant foods. I feel like they're survival foods. I feel like the animal foods are the most nutrient-rich foods. If people want to, have the ability or they want to eat some plant fruits from time to time, I think that if they're carefully selected, that can be totally reasonable for people. Just take an honest assessment of how they affect you,
Mm-hmm. Yeah, this is great. That's what I do. I'll just end by saying I eat mostly animal foods and I love it, but I do some fermented vegetables and I think it's just good to keep some sort of normalcy. I mean, if I'm out for dinner and I want to do something, I can eat it and then I'm going to go back to my normal diet the next day. So just figure it out for yourself, figure out what works for you.
The one thing I'll mention before we go, just hold on for one moment, because you mentioned the fermented foods and I wanted to mention that. People always ask me about fermented foods. What about fermented foods? You and I dialogued about this before we got on the other day. And, it's really interesting. I'm not super excited about fermented foods, but you pointed out something to me that I thought was really interesting. And that's the fact that when you ferment brassica vegetables, many of the isothiocyanates are reduced. So fermentation is a way that you can detoxify brassica vegetables. So, when you get sauerkraut, it's cabbage, which is full of all the isothiocyanates, the allyl isothiocyanate, all that was, sort of part of the cabbage, but the fermentation process gets rid of that. So that is really an interesting part of the whole equation, that the fermentation might make the cabbage more palatable, or it might make it less toxic. I don't think that humans need probiotics. That's a whole nother podcast. I don't think that humans need the lactobacillus in these things at all. I do think the fermentation can make the sauerkraut or the cabbage less toxic. The other word of caution I would give people is that the acid in the fermented foods is not good for the mouth. I have a number of clients who are dentists. I've talked to them about this extensively, and there are cases of people really messing up their dentition by over-consuming fermented foods, whether it's kombucha or sauerkraut or any of these things. The acid in the mouth is not good, whether it's from citrus fruit or kombucha or apple cider vinegar. These are damaging your enamel. They are damaging your teeth. And so I do not think this is beneficial. Occasionally, probably no problem, but regular, extensive consumption of fermented fruits, vegetables, kombucha, I believe will be a net negative for your dental health. So I just wanted to put that in there for people.
Yeah, that's interesting. I wonder if the dental health was, caused by other things too. I mean, there could be many factors. A poor diet and carbs and sugar lead to poor dental health as well. But I mean, there's always something to think about here with these different plant foods. So
yeah.
All right.
Absolutely. Well, thanks for having me on, man.
Where can we find you?
Okay, so I see patients for functional medicine consultations. You can email me at paulsaladinomd@gmail.com. I have a YouTube channel, which is Paul Saladino MD. I'm on Instagram at Paul Saladino MD. I'm on Twitter at MD Saladino. I have a Facebook, Paul Saladino MD. I have a Patreon, which is Paul Saladino MD. Obviously, that's a lot of places to reach me. I would say that the best thing is direct mail if you want to get in touch with me. Then Instagram. I'm usually pretty good, and over a course of a day or two, I can keep up with my DMs and messages most of the time. It's pretty hard to keep track of the Facebook messages, but if people want to reach out to me there, I'll sometimes see them. I need to have somebody probably help me with that in the future. And then the YouTube comments are pretty hard to answer. But I appreciate your comments on my stuff and the conversation that happens there. And I will continue to put out lots of good YouTube stuff in the future. So those are the main things. I also have a website, which is directly mine, which is paulsaladinomd.com.
Awesome. And don't ask him stupid questions and waste his time. Don't keep asking where he gets his salmon roe. If you have a real question or if you want to get a consult with him, then you can email him. But I just want to throw this out to people just because it helps everyone in this world.
Yeah, I mean, I'll try to answer all the questions I can, but if you read the comments and you look at my previous posts, you'll see answers to most of the questions already on there. But we'll try and. Yeah.
All right, awesome. Maybe we'll have to do part 3 in a while. we'll save up for maybe a few months and
longest podcast in history. Well, I'm excited to hang out with you soon in LA and be in the movie, man, so people can see me there too.
Awesome, let's do it. All right,
man. Thank you.
All right, see ya.
Bye.
Wow, a lot to think about there. I'm still eating my bit of fermented vegetables, avocado, and coffee, no matter what Paul has to say. Remember, there's a whole array of ways to support the show and the film, from $2 on Patreon to promoting the film and getting your name in the credits on Indiegogo, all the way up to a giant $200 box of grass-fed meat delivered to your door. Find all the links in the show notes and find me on Instagram and YouTube and Twitter and all the places. See you next week with an insanely great show with Dr. Frank Mitloehner, who destroys every climate change, animal agriculture, CO2, water myth ever created. Until then, stay happy and healthy, friends.